So enter climate change. So we have these overly dense forests that have been missing their fire ecologies. In Southern California, the chaparral systems are getting too much fire, too many ignitions. And so we're seeing vegetation start to change. Then we are in the middle of arguably sort of a once in a millennia drought. So from 2012 to 2015, we had 169 million trees die off throughout California. And those are actually bigger trees from this sort of drought-driven beetle kill pandemic, killed off a lot of our big trees. This is a picture in Shaver Lake area, and you had 80 to 90% tree mortality in that area. There was a plot of managed forest land that had been selectively logged by Southern California Edison and then managed with prescribed fire for about 50 years. They had about 25% tree mortality because those trees weren't competing for that scarce water. And so it was a much more resilient forest. So when the creek fire broke out around Shaver Lake last summer, the heat signature on that fire was so that it created a pyrocumulus cloud up to 50,000 feet high. I think this summer, everyone is getting much more familiar with pyrocumulus, but this one was a monster. Fire scientists said that they hadn't seen that scale of heat intensity on a fire, this phenomenon called standing combustion. So active flames throughout like 100,000 acre footprint. They hadn't seen that in real life with the exception of the Tokyo fire bombings and the bombings of Dresden. So it's really important to recognize just the scale of intensity on these landscapes. And I've gone up to the creek fire area and there's nothing growing back. I mean, not even sort of type change conversion where you're getting shrubs or invasive grasses. It is just what we call a nuked landscape. And so that's really devastating when we're getting that heat signature on these fires. Because they're way outside their natural ecological norms, and then it causes cascading climate events. So that then exacerbates drought conditions because that's devastating your watershed, right? The mountains are designed to actually hold the water for us. They're designed to be sort of natural reservoirs and then percolate it out throughout the summer. They're designed to hold that snowpack into the early summer. And so when they're not doing that, it means we lose our water really early. So it exacerbates drought conditions, causes mudslides, and then the human impacts in terms of our own health impacts on smoke. There's now links between PM 2.5, so the particulates in smoke, and increased rates of COVID. It really impacts your respiratory system. It impacts your immune system. It's really dangerous. And then also just the human impacts, right? We had 250,000 people displaced last summer. We had 50,000 people displaced from the Caldor fire. This summer, I had a family staying with me for 2 weeks, crammed into a little home. And so, all of us are really, it's that compounded crisis on people who are being deeply traumatized by these wildfires. But there's a little bit of hope on the horizon. So this is a forest actually in Baja, California, that was never logged. It has been ecologically managed with fire throughout its lifetime, and it is remaining at a hotter climate zone, a resilient ecological forest. So when you think about your forests in Southern California that are starting to convert to chaparral, in part because of fire, we can get those managed into a way, if we put those right resources in and good management, to be able to retain those forests. But it's going to require thinning them out so that they have the tools to compete and to be resilient with the new climate conditions that they're facing. We have been scaling up our actions in California over the last 5 years. So this is sort of the fuel reduction that CAL FIRE has done over the last few years. So we've increased from 19,000 acres to 105,000 acres treated. And that's going to continue to increase because our resources are increasing dramatically on this fire resilience front. So we had been investing in, and this is in addition to fire suppression. So this is in addition to your firefighters on the ground. And so we went from $200 million to a dip from COVID, it's to $75 million to this year, we're investing in $1.5 billion in fire resilience. So I know a lot of you are asking, what's fire resilience? So this is really a question of how do we live with fire? How do we return fire back to its natural intensity? How do we ensure that communities that have moved into these high fire risk zones are able to withstand it? And that we are able to withstand sort of the intensity and the increased intensity of fire from climate change. So there's really three fronts of fire resilience, and it's really critical to understand that all three fronts are needed, and that none of these are able to stand alone. So what we do is we lessen the intensity of fire on the landscape by trying to get that landscape back to its normal density, its natural density, so that it can have more of a natural fire regime. So in Southern California, where you have invasive grasses coming in, we want to get those back to native chaparral. In Southern California, where you have forests converting to shrublands, we want to get those back to forests. Where you have green forest standing, we want to thin those out so that when fire comes through, it's not going to be that crown fire that wipes out the entire ecology. Instead, it's a low intensity ground fire that then helps seeds germinate and is a healthy fire. What we've also noticed is that when you lower the fuel intensity on the landscape, it dramatically decreases the ember cast. So the amount of embers blowing into a neighborhood, right? So the ember cast is decreased dramatically when the intensity of the fire is lessened, which means that fuel load is lessened. The next area is interventions around communities. So this is where we're putting in shaded fuel breaks, especially along roads. Allow firefighters to take a stand, allow communities to evacuate during a fire, and allow firefighters to be able to have some sort of tools to be able to get into a fire. The last area is interventions inside of a community. So this is where you're doing your defensible space and home hardening to be able to get of being able to ensure that your home is not then the center of that fire. So there's a lot of tools and tactics across this, and that $1.5 billion is investing across all three of these fronts to ensure that we are lessening the intensity of fires. And then we're also going to be investing in sort of structural reforms to ensure that all of these resilience measures are actually invested on the landscape. So I'm just going to give you guys a couple more examples here. And so when we're talking about landscape scale interventions, this is an example of fuel reduction done in the North Complex fire by the Sierra Nevada Conservancy. You can see that where the fire burned really hot and intensely until it hit the fuel reduction that had been done and the treatments underneath the forest. So that fire actually continued into those green trees, but underneath the canopy, and then it self-arrested. This saved the town of Quincy last summer. This is an example of a shaded fuel break. So I think a lot of people go, what, a fuel break? Why are you putting this here? Just put it immediately around a home, only do defensible space. A fuel break is where the fuel along roadways or areas that are tactically significant for firefighters so that they can stage equipment. This works for shrubs, this works for trees. And so we saw this take place in the Calder fire. I just stood in one last week where the fire came right up to a neighborhood in Myers in South Lake Tahoe. And that shaded fuel break, it was burning the tree canopies all the way through. It hit that 600-foot deep shaded fuel break, and the trees were standing and the neighborhood was standing. The homeowner came out, she was in tears because she hadn't realized that the fire had actually come up to her fence. But it was because of that fuel break that firefighters were able to access that point, take a stand. That fire dropped from 150-foot flame length, which is a 15-story building, down to 5 feet, which meant that their fire hoses were effective against it. So it's really important to understand, oftentimes fuel breaks get misconstrued as preordained containment lines of the fire. But what they are is a tactical advantage. They are often along roads so communities can escape. They are areas where firefighters can safely take a stand to access a fire and make a stand against and defend homes and neighborhoods and communities. Sometimes you're going to see them sort of a mile away from a community because they'll be on sort of a strategic ridgetop where firefighters can tactically take a stand and try to reduce that ember cast to keep it away from neighborhoods. But when your fires are spotting 3 miles in advance, those fuel breaks are not designed to stop the front of a wind-driven fire. But what I have is a picture here of firefighters and the National Guard crews putting in fuel breaks in Southern California. And you can also see an effective fuel break in the campfire below. This one actually arrested the flank of the campfire. And so it saved the town of Sterling City when we had that big fire in Paradise. So also big investments in defensible space. We started a pilot program to actually do direct intervention, as well as investing in the UC Fire Advisor program and defensible space inspectors, which get education to homeowners to do this work. Here's some examples. Of this $1.5 billion investment, $500 million already went out the door in an emergency appropriation in April. Some of that money went down to about $68 million went to Southern California conservancies, including the Santa Monica Mountains Conservancy. And so between April and July, they worked incredibly hard to get fuel reduction and safety measures on the landscape early. So when we're talking about sort of that community and that home hardening and lowering road ignitions, here's an example of some fuel reduction that they did along Highway 101 with these resilience dollars back in April and May to reduce ignitions along the roadway. Other things that they put out were folks to try to be sort of community awareness and safety advisors who go out as part of a community watch during red flag warnings. So over 4th of July weekend, they found an illegal cache of fireworks that people were setting off in LA, and they were able to stop them from causing a wildfire that night when they were setting off those fireworks. And then a lot of education and outreach is what we're investing in. So investing in local CHIPS programs that help homeowners do this kind of defensible space so that when a fire comes through, it doesn't consume the home. There's not enough fuel around the home, and that the home is hardened against Embercast. So again, we're really doing a whole lot with these fire prevention grants that go down to like Orange County gets fire prevention grants. Your local water district could get fire prevention grants. So we have hundreds of millions of dollars in those fire prevention grants to tailor something to your community. The key point here is that we're also trying to make this regionally driven. And I think I'm over time here, but we're investing also in the workforce to be able to remove woody biomass so that we don't have to pile burn it, and wood innovations such as building up to 18 stories with something called cross-laminated timber that replaces steel and concrete in skyscrapers. So it allows us to use what otherwise would be pile burned wood and wood from salvages from fire and put it into sequestered carbon. We're increasing the workforce to do this work. And most importantly, we're making this regionally driven. So Southern California has a different fire adapted ecology than Northern California. And so it's really important that then the local collaboratives and local leaders have the input so that those 3 layers of resilience are adapted to the local fire ecology. So huge investment we're making is in this regional forest and fire capacity program. A great example of a partner is the regional forest. One of our partners is the San Diego Resource Conservation District. And as you can see, this is just a picture of San Diego County with the mosaic of landowners on the land. And so these dollars only make sense if there's a cohesive strategy for the entire region to achieve that fire resilience. And so we put dollars into the local resource conservation district to be able to make that plan for fire resilience for the region. And then all of our dollars from our fire prevention grants, our forest health grants, out of that 1.5 billion, all of these grant dollars go then into the projects identified by these regional collaboratives so that they're locally adapted. So here's an example of some early dollars from that April appropriation that went out to San Diego Resource Conservation District. They did 250 chipping projects around the area and really helped communities increase. They also put in sort of a fuel reduction area up in some of these mountains so that they could help communities escape during the fire, and that was done with these early action dollars. So again, of that $1.5 billion, $500 million has already gone out on the ground. The legislature just approved $1 billion on Thursday, and the governor's going to be signing that next week so that it will be on the landscape for all of us. So wildfire resilience, we know what to do. and it is a matter of scaling it. And now we have the resources to scale it. And it is going to take a full team effort to get this done. And so I'm so grateful for your partnerships, your innovation, and your work on this front, because we are going to be leaving a legacy that not only keeps our community safe today, but in the next 100 years, they're going to look back at us and say, we did it right. Thank you.
Thank you, Jessica. What a great overview and a great foundation for us to kind of build from today. Lots of really great information, wonderful, resources that I know many of our organizations that are here today, as well as the agencies, are going to want to follow up regarding those grant programs, of course. But it also, certainly, you're giving us a framework to build from today and our 2 days to follow. So we appreciate your time. We know you've got limited amount of time and you're not available for questions, but any questions we do have, we'll pass along to you and your team, and we'll go from there. And thank you again. It's been great having you this morning. And for our audience, if you've got questions, go ahead and put those in the Q&A feature, and we will certainly, there was a question about having your slides being made available. So we'll follow up with you, especially for teaching purposes. It's really great. And we'll certainly make the recording available for others. Thank you again. And I'm sure we'll be talking soon with you. So I understand that there's a little bit of a technical difficulty seeing the slides that I started to share, and I'm wanting to get to our to introduce our moderators. So Drew, I'm going to try sharing my screen, and you let me know if you all can see it. So I'm currently sharing. I'm curious what folks are seeing.
We can see it.
Great. Okay, that helps me know that. Thank you. Well, it's now my pleasure to introduce to you Marilyn Raphael, our moderator for our first panel. Wow, I'm still kind of amazed at all the information that Jessica shared with us. So Marilyn, I think you're in a really great position to build off of that. But let me finish the introduction. Marilyn is the new director of UCLA's Institute of the Environment and Sustainability at UCLA, of course. We know that you were interim director, but there was a recent decision. So congratulations on that, formalizing your role as director. We know that you've participated in the early formation of IOES, and we're excited to have you here today to bring that expertise and that perspective to guide our first panel discussion with a focus on weather and climate. So with that, I think we can pass it on to you, Marilyn, and certainly for our audience, all the bios for not only our moderators and panelists, those are in our program. We're trying to get to the presentation so then we can get to some really great discussion and dialogue. And with that, I will pass it to you, Marilyn.
Thank you, Eileen. I'm pleased to represent the Institute of the Environment and Sustainability at this symposium on wildfire. At the Institute, we're keenly interested and actively engaged in investigating and providing solutions for environmental problems like wildfires. Now, it's my pleasure to introduce our panelists who will be providing short presentations. Today, we are fortunate to have some of the foremost experts on climate, weather, water, and wildfire on our first panel. Before they begin their presentations, and in the interest of time, I'll make just a very brief introduction. Additional information about each panelist is available with the symposium information. The presentations will be given in the following order. First, Rong, who is a professor in the Department of Atmospheric and Oceanic Sciences at UCLA. Followed by Tom Rolinski, a fire scientist at Southern California Edison. Next slide. Then we will have Max Moritz. He is he's at the Corporate Extension Wildfire. I said that wrongly, let me rephrase. He is a Corporate Extension Wildfire Specialist at Brent School of Environmental Science and Management at UCSB. Our final panelist will be Wallace Meyer, the Director of the Robert J. Bernard Field Station, Claremont Colleges, and Associate Professor of Biology at Pomona College. We will begin our presentations with Dr. Rong Fu. Rong?
Yeah, can you, okay, good. Thank you so much, Marilyn. It is a great pleasure for me to be able to participate in and learn from this panel. As Marilyn introduced, I'm a professor in the Atmospheric Oceanic Science Department. I'm also the director of the Joint Institute for Regional Earth System Science and Engineer at the UCLA. And my research focus on understand the rainfall variability, especially drought. I'm currently a co-lead of the National Oceanic Atmospheric Administration Drought Task Force. Since I moved to California about 5 years ago, I experienced firsthand the impact of a wildfire. Therefore, I direct my research to the coupling between drought, wildfire, and the heat waves. And I'm so glad to have this opportunity to learn more about wildfires. I'm motivated to work with wildfire community because wildfire are not only affected by drought, but also potentially intensify drought. And we have a very limited understanding on how wildfire affect the drought, which is really an important open question for improved drought early warning. So therefore, next slide. Yeah, so therefore I would like to share with you this opinion paper published in EOS on behalf of the drought task force as our invitation for collaboration that address compound effect of drought, wildfire, and heat waves. And symposium like this is exactly what needed to advance research in this area. Next slide. So we know from literature that the increase of fire weather, especially the vapor pressure deficit due to warmer surface temperature, is the leading cause of increasing large fire over California and the Western US. And here is just example showing that where this histogram shows the acreage burned by large fire over Western US, and the black line shows the vapor pressure deficit change, VPD. And if we look at the map, we can see that California as a whole, as well as Western Nevada and the Southern Arizona are especially, we see the increased VPD are especially strong, and mainly due to increase of surface temperature. The question is, to what extent such an increase of vapor pressure deficit is due to the changing weather pattern as a part of the natural climate variability, or and versus the impact of climate change. Next slide. So there have been many modeling studies to address this question, and they show that the climate change definitely at least contribute to the increase of vapor pressure deficit. So here we use an observational approach to estimate the relative contribution between changing weather pattern that is largely natural part of the climate versus the climate changing. Here, climate changing is especially referred to human-induced increase of greenhouse gases. So the way this works is we estimate the vapor pressure deficit change due to weather pattern based on the historical record, specifically from 1979 to 2010. And then we compare that with observed VPD and to the VPD that would be for the same weather pattern if that occurred in the past. So, so that represents the VPD changing associated with a weather pattern. And here you can see that the black line on the right panel represent the observed VPD anomalies, anomaly departure from the multi-year mean, 4 decades mean. And versus the VPD that we would expect from weather pattern, which is blue curve here. And as you can see from this chart, after 2000, the gap between observed VPD and VPD we would expect from weather pattern change grow substantially. And the difference here, the gap here actually represent the impact of climate change. And if we're looking at California from the map on the left, you can see that on average, only 36% of the increase of VPD can be attributed to the weather pattern change. And in another word, 2/3 are actually due to climate change. So if we consider the error range, that's a 30% to 46% at a 95% confidence level. So in general, that the over Western US, that the natural changing of weather pattern contribute 1/3 of the increased VPD, whereas climate changing contribute 2/3. Next slide. So now let's look at the September 2020 last year, when the August complex fire and the creek fire occurred. So here we can see that the red curve here is observed VPD, whereas the black curve is the VPD we would expect from just the anomalous weather pattern. And so as you can see that in middle August and early September, right before and during the August complex fire and the creek fire, that the weather pattern change only explain about half of the unprecedented high VPD. And this, the rest of them has to be explained by climate change. Okay, this is perfect. That's okay. I can go. So that's so in summary, the observational estimate we made suggests that the natural climate variability or changing weather pattern only explain 1/3 of the increasing VPD or fire weather in the past 4 decades. 2/3 has to be explained by surface warming due to the greenhouse forced climate change. And if we look at the climate model attribution, that these are the estimate based on the climate model used by the latest IPCC, the 6th report. Actually, model suggests 90% is due to the anthropogenic forced change. So this really, we were surprised by this, because based on the climate projection, we generally expect the natural variability, the climate change for the climate changing effect will surpass natural variability after middle 21st century. But these studies suggest actually we have already passed the turning point where the fire weather, changing of fire weather now is mainly due to climate change, and natural variability influence become secondary. And that's the conclusion of this presentation. Thank you very much.
Thank you, Rong Fu. Our next panelist is Tom Rolinski. Tom.
All right. Good morning, everybody. Can I be heard?
Yes.
Yes.
Okay, fantastic. Good morning. Good to be with you here. The title of my talk here is The Effects of Climate Change on Fire Season. Probably maybe a little more appropriate title would be how maybe a method in which we can maybe determine the length of fire season. So next slide. So before I really get into all the things I want to show you here this morning, I just want to get through a few things here just to just a kind of sort of housekeeping items here. First of all, we're going to be looking at in the following charts. We're going to be focusing on what we call fire climate zones, and we're going to be focusing on fire climate zone 2, which is the red area there, just inland from the coast. Also, the data that I'm using here is we're using the energy release component. We have spatial statistics, spatial averages, and spatial maximums across these fire climate zones. But again, for the period 1980 to 2020. And then we're also using a fire data set from 1992 to 2017 that contains all fires greater than 1/10 of an acre. So again, we're going to be just focusing on fire climate zone 2. Next slide, please. Okay, so the energy release component is what we're going to be focusing on here this morning, or what I'll be focusing on here for this study. And basically, it's just a measure of the potential energy that's available for release at the flaming front of the fire. And it's due to the amount of moisture in the vegetation. So it actually, it's a good measure for looking at long-term vegetation dryness. And therefore, it makes it a very good metric for us to use for assessing fire season severity and fire season length. And when I talk about fire season severity, it's how fires behave. Really won't get into that part here, really just looking at fire season length. Next slide. Okay, and just to demonstrate the relationship that energy release component, or ERC, has with fires, if we look at fire size, again, this is just over fire climate zone 2, and this is looking at 1992 to 2017. This is just looking at all fire sizes, but you can see this is exactly what we would expect to see. The higher the ERC, basically the drier the fuels, and we're seeing with higher ERC values, larger fires occurring with the slant of the scatter plot here off to the right. So again, associated with higher ERC values, exactly what we'd want to see. Next slide. So the first thing that we, in this process of using ERC to determine fire season length, the first thing we want to do is find an ERC threshold that relates to significant fire activity. So what this scatter plot shows is there's two different ERCs that we can look at here that we can use. Again, this is looking at fire climate zone 2. These are fire sizes associated with the blue ERC values, which is the spatial average over that fire climate zone, or the red, which is the spatial maximum. We're going to use the spatial maximum for the purposes of this presentation. And essentially, we want to do this because we want to look at the larger fires here. So this is 1,000 acres or greater in relationship to both ERC average and ERC spatial maximum. And this is the way this is the method in which we go about establishing a threshold. We can look to see over the course of our fire history where we start seeing larger fires occurring. And so in this case, we start seeing them, if we use the spatial maximum, around 65. We're going to use actually 60 just to be on the safe side. And I'll show you how this works here. Next slide. So the next thing we do is we're going to start to plot ERC for all the years. This is just looking at 2018 as an example. We picked our ERC threshold from the previous slide here at ERC 60. And what we want to look at here is the number of days, number of consecutive days, and that's key, the number of consecutive days in which we have energy release component above our threshold. Now this gets really tricky, and I'm going to be transparent with you because there's lots of knobs here to sort of change, and depending on how we change things can really make a difference in our overall determination of fire season length. So using this method. So this is not bulletproof or anything. I think there's a lot of room for for maturity here, but again, just sort of going through this method. So we can see that ERC sort of jumps around a lot and goes in and out of our threshold. So the other thing we want to do is to sort of simplify things is applying a smoothing curve to this to the ERC data. So next slide. So here's our smoothing function that we've applied and sort of smooths things out a bit, and makes it a little easier for us to kind of sort of step back and look at the overall picture and sort of get rid of some of the noise here in ERC. But so what we can see now is we basically have a window, a defined window of where ERC is above our threshold that we picked. Again, number of consecutive days. Now, the key thing here is that if we look at, again, this is 2018, if we look at sort of the October period, if you recall back in October 12th of 2018, we had a pretty significant lightning event across Southern California, produced pretty good widespread precipitation. So you see a pretty drastic drop in the energy release component. Is that enough to sort of end fire season? Well, if you start to examine what happened afterwards, and we can set sort of these our criteria for how long a period of time does ERC drop below our threshold before it goes back up. Again, all of that is very flexible and can really alter our end results. But in this case, if we look at 2018, we see the ERC go significantly higher above our threshold later in November, and we had our Woolsey fire during that peak. So we definitely want to include that in our fire season definition here, at least for how we're defining for 2018. But again, a lot of little tweaks here that we can make. So let's go to the next slide. So the bottom line is here, if we do this for every year in our historical data set over all our fire climate zones, and again, I'm just picking fire climate zone 2 as an example. It's the same thing for every fire climate zone. But we can take a look at the starting date and the ending date of when we had of our consecutive period of ERC above our threshold. And if we start to look at over the course of time, we have some trend lines here. We can see that in this particular zone, we have generally a trend of earlier start of our fire season and a later end to our fire season. And if you count up all the days in between the starting and ending times, you get what the plot at the bottom here that just shows you the number of consecutive days for each year. And we can see there has been an upward trend since 1980 across this fire climate zone. So it is interesting to see just using this method of analyzing the length of fire season and how that's changing. And then of course we can look at our climate models and determine what kind of future changes we can expect in the length of fire season. Next slide, and this is my last slide here. And so again, ERC is a good metric for assessing fire season length. I didn't really focus on, or I didn't really talk about severity, but again, the higher the energy release component value, we see that there's larger fires. That would imply they're more difficult to suppress, and there's more extreme fire behavior associated with those larger fires. So again, that's sort of for another talk. And then again, just leveraging our historical data set to determine these spatial statistics that are aggregated over our fire climate zones. And then again, estimating the length of fire season by setting the ERC thresholds, and then determining how many consecutive days we are above that threshold. And then of course, when we sort of look at the entire historical period, we can see trends emerging in our fire season length. So that's all I have, and I'll pass it back to you, Marilyn. Thank you.
Thank you, Tom, for a really interesting presentation. I should say that we will have questions coming out of these presentations at the end. So We move right on now to our third speaker, Max Moritz. Max?
I'm here. Hi there. Well, thank you to the organizers and also to those attending. I am a statewide cooperative extension wildfire specialist, and I'm also an adjunct professor at UC Santa Barbara in the Bren School. And what I wanted to talk today is about some of the science behind predicting fire under climate change and what we've learned basically about the difference when we include human development variables and what that shows us. So next, please. Okay, next again. Thanks. So if you've heard or learned anything about fire from the research community, you'll often see this fire behavior triangle used. This is very useful for trying to predict things like flame lengths or rates of spread or fire intensities based on the weather conditions, the fuel conditions, and the topography during an individual fire, right? But if you're going to look at fire over longer scales of time and space, so next slide, you might use data sets like these. This is a global look at fire over a given year back in 2012. And you see fire marching across the planet in different months. And these are the kinds of data sets that we have used, longer term fire occurrence data sets to train models over fairly large areas. We produce them for the globe, for North America, for California. And this tells us over the longer term something about fire frequencies, where we're likely to see fire, which areas are likely to be fire free, almost always, and why. Next slide. Next, so we have fire regime controls that we binned into three sort of categories. One is the variables that dictate fuel amount, right? The environmental constraints on productivity. Basically, how fast is vegetation growing? The second is fire season. What variables climatically control the length and severity of the window in time in which flammability, the vegetation that is there, is actually flammable. Next. And then how do ignitions coincide with conditions that promote fuel growth and the fire season, allowing flammability? Next. Those three categories we've sort of combined into a fire regime triangle. So we have the fire behavior triangle, which we saw earlier at the scale of individual events. And then we have fire regime triangle like this, which helps us understand fire frequencies, at least, over longer scales of space and time. Next. Well, at the global scale, what we found is that you can actually use the climate variables to drive the patterns of fuel productivity on one hand and the fire season length and severity on the other. And you can kind of assume that humans at broad spatial scales don't play much of a role. There's very little ignition limitation shown, for example, at coarse scales. But when you zoom into, say, the scale of California, which we see here, you see the fires in orange over the ecoregions in different colors. At this scale, we can't tell the whole story with just the climate variables, right? At this scale, at finer scales, you have to start incorporating things like, next. This is the infrastructure for the power line corridors across the state. We have to include things like this. We have to include road densities. We have to include housing development patterns. And if we don't, at finer scales, we actually get the answers wrong. We actually don't create very realistic models for past fires or for future fire probabilities. Next. So at these finer scales, we've built models for a variety of uses. One is actually for CAL FIRE. It underpins their avoided emissions program. We've been able to differentiate the sensitivity in the model between the biophysical variables, what we're calling here the natural contribution of the variables. And there's an image that shows basically the sensitivity of fire frequencies to all of the biophysical variables that we have in the model. And then next, here's a map of the sensitivity of fire frequencies in the model to all the anthropogenic variables, road densities, the housing patterns, et cetera, et cetera. And we can see from this that human development actually can push fire probabilities up, that's the red colors, or down. and that's the green colors. That's a really important finding. Next. And what that means when we look at the functional response of fire, so the vertical y-axis here, you can think of as the sensitivity of the model of fire probabilities or fire frequencies to housing density along the horizontal x-axis here. And we have this hump-shaped response, which others have found, and it's probably a fairly generic response of fire to human development. And the way to interpret this is that there's some sort of background level of fire under very low housing densities that rises as you develop a landscape and then peaks, and then it declines sharply. And that decline as you further and further urbanize a landscape is because there's less contiguous landscape to burn, there's more organized fire suppression, and basically it drives down fire activity to relatively low levels. And this finding actually tells us that we have hope, right? Even though we are going to slowly, hopefully make progress on greenhouse gas emissions and mitigating climate change effects. This also tells us that in the short term, land use and urban planning, where and how we build our communities, actually has a strong effect on fire probabilities, right? So it's not just our exposure to fire, where and how we build, but it also feeds back to affect future fire probabilities. And so if we use that knowledge in our policy and planning, we can actually adapt to some degree if we're willing to use land use and urban planning as a tool. Next. This is just a little foreshadowing. I'll end with this. We have coming up in the next series, there's some discussions over what do we do with that information? How do we then build smarter? How can we site and design with density as one of the criteria to reduce our risk and make our communities more survivable? Next. That's it. Thank you. And I'll take questions at the end.
Thank you very much, Max. As he said, questions at the end. Our final panelist for this morning is Wallace Meyer.
Those are all. Yes.
Yeah, the other direction. I promise you there is another presentation. Right. Wallace Meyer will talk about the impact of fire on ecosystem function and biodiversity in Southern California. Wallace?
Hi, hello, everyone. For some reason, my video is not being allowed to be turned on, but hopefully you can hear me at least. Okay. So I'm just going to go without video. So hello, everyone. Glad to be with you virtually. Can you skip my title slide? So today I'm going to talk to you briefly and discuss research from my lab at Pomona College that hopefully helps inform us about the effects of fire on both ecosystem and biodiversity. I started with this picture of Tessa fixing some traps in an area that burned in 2013 to highlight that most of the research was conducted by some amazing and dedicated undergraduate researchers, many of whom are first authors on the publications that will be highlighted in this presentation. All right, next slide. So most of the research was conducted at the Robert J. Bernard Field Station, of which I'm the director. It is located on the eastern edge of Los Angeles County, just north of the Claremont Colleges on Route 66. The BFS offers many opportunities to explore the impacts of habitat modifications and disturbances like fire, because it harbors a large area of relatively intact California sage scrub, which is highlighted by the shrub bubble. California sage scrub is an endangered ecosystem that once covered much of the lowland areas of Southern California, but now is commonly found in small isolated fragments. It also harbors an area we refer to as the non-native grassland, which is a disturbed area that is now dominated by European bromeless grasses. In addition, the BFS is surrounded by a variety of suburban areas highlighted by the pictures on your left, and has experienced 2 human-started fires in 2013 and 2017, which are highlighted by pictures of students studying the impacts of these fires on the right part of your slide. So while we have studied the direct impacts of these fires, most of the research I'm going to talk to you about today will explore differences in ecosystem function and biodiversity between the sage scrub and the grassland habitats as a proxy for understanding fire impacts. Next slide, please. The reason for this is that type conversion of sage scrub to non-native grasslands is a common result from frequent fires and is associated with the grass fire cycle. So the grass fire cycle is easy to understand, but tricky when you're making a visual aid. So let me explain. Let's say there is a nice piece of native sage scrub that experiences a fire. After the fire, non-native grasses are quick to colonize the disturbed area. Consequently, in the years following the fire, you will likely have a transitional area with recovering sage scrub shrubs and abundant non-native grasses in the interstitial spaces. The problem is that these non-native grasses are annuals that set seeds and die at the beginning of the long, hot, dry season in our Mediterranean climate. Dead, thin grass litter increases ignition probabilities, making fires more likely. If grasses facilitate a fire soon after the first fire, sage scrub shrubs will have a difficult time recovering, as the seed bank will be spent and resprouting plants will have few energy resources left. This will result in type conversion of the area into a non-native grassland, which will further perpetuate reduced fire return intervals and the grass fire cycle. Because this is a common phenomenon across Southern California, comparing differences between these two habitats provides insights into how fire may impact key ecosystem services. So when I arrived at Pomona College, thank you for switching the slides. So when I arrived at Pomona College, my first senior thesis student was interested in studying differences in carbon storage between sage scrub and non-native grasslands. To explore carbon storage in these two habitats, we focused on three components: the above ground biomass, which involved an effort of creating models to predict carbon storage in above ground plant structures, the litter component, and the soil. The two main results I hope to highlight here is that carbon storage in each component is significantly higher in the sage scrub than it is in the non-native grassland, and that much more carbon is stored in the soil than in the other components, especially when you consider that we were only quantifying carbon in the top 10 centimeters of soil. Next slide. So my next cohort of students correctly highlighted that research at the BFS may fail to account for the multiple environmental factors that may influence nutrient storage across the region. So we set out to explore how carbon storage differs between sage scrub and type converted areas across a coast to inland gradient. We chose sites that had both sage scrub and adjacent areas that were type converted either to non-native grasslands, highlighted in the lighter green, or non-native forelands dominated by invasive mustard species, highlighted in mustard yellow. We found that the impact of type conversion on carbon storage was contingent on the type of invasive plant. Non-native grasslands stored less carbon than sage scrub, and there is evidence that type conversion to non-native mustard lands may result in enhanced carbon storage. When you scale the numbers up, we calculated that type conversion of sage scrub to non-native grasslands results in a loss of 940 tons of carbon per kilometer squared, demonstrating that these conversions can act as significant regional contributors to greenhouse gas emissions. Next slide, please. So these results on soil carbon correspond well with results from a litter decomposition experiment conducted in both habitats at the BFS. There's a lot to unpack in this slide, but what I want to highlight is that decomposition, or the breakdown of plant material resulting in carbon loss to the atmosphere, is higher in the non-native grassland than it is in the sage scrub habitat, suggesting that these habitat modifications associated with fire negatively influence key ecosystem functions. All right, next slide. All right, finally, I just wanted to highlight that type conversion also impacts biodiversity. In my lab, we focus lots of our attention on how these disturbances and habitat modifications influence arthropod assemblages. We have conducted pitfall trapping across the BFS for the past 9 years using the test tubes in the picture on your upper left, which are placed in buried PVC pipes when activated and covered with a rain top that allows us to collect ground-dwelling arthropods that are crawling around in the soil in these different habitats. We have also been monitoring butterfly assemblages by conducting monthly surveys for over 6 years. Our butterfly route is highlighted in the middle figure. I do not expect you to interpret the graphs, and in 7 minutes, I would never have the time to explain the details and the various approaches across our different studies. So I'm just going to state the key findings. In general, ground-dwelling and flying arthropods are not impacted by the direct effects of fire. While there is not cross-taxa congruence, which means that patterns for one taxa do not predict patterns for another arthropod taxa, in general, native arthropod richness is reduced in the non-native grassland, and sage scrub harbors unique assemblages that may be lost during type conversion. All right, next slide. So in conclusion, and I know this is brief, I hope this brief presentation provided you with some insights on how frequent fires and the resulting type conversion unfortunately deleteriously impact ecosystem function and biodiversity. I, of course, would be happy to elaborate and answer any questions you have during the question and answer session. Thank you.
Thank you. Thank you, Max. Now we get to the question and answer portion of this panel. We've covered a lot of ground, and there are a lot of interesting questions to ask, and I already have some. What I want to say is that when I ask the questions, they might look likely to be answered by one particular panelist, but please feel free, all of you or each of you, to chime in where you think the answer can be augmented. And also the questions, there are lots of different bits of information given today, and so the questions will probably jump around. But what I want to try and do is to give each of you a chance to talk a little bit more about what you've presented. The first thing, just to kind of set the stage, and Rong, you might be the one best suited to answering this, but as I said, anyone else can chip in, is as a direct consequence of climate warming and associated changes to fire weather, should we expect, actually, should we expect more wildfires, an increase in the frequency of wildfires, that's two different things, or both in the coming years?
Thank you. So wildfire, of course, not only depend on the climate, but also fuel load, and which is linked to climate and many other factors. But just from the fire weather point of view, we would expect increase of fire weather and a higher vapor pressure deficit, because that's dominant by warming of surface temperature. And warming of surface temperature is quite well linked to the increase of greenhouse gas. And I also learned from colleague in the fire community that the VPD is not only influence the frequency, but also intensity. And I will defer to fire expert to provide a more comprehensive answer on how climate change would affect fire.
Okay, thank you. Would anyone else like to weigh in on that?
Well, this is Max. My lab has produced fire and climate change projections for over a decade. And one of the things we've learned is that it really depends on which ecosystem you're talking about, because many of them are relatively fuel abundant, let's say. And if the future for that particular area is warmer and drier, you might see increases in fire there because there's plenty of fuel, and maybe what's limiting is the window in time in which those fuels are actually flammable. Or if you have a much drier, more fuel limited ecosystem, a warmer, wetter future, could lead to more fire, more productivity and more fire. So it really depends on where you are. And complicating that is that there are many, many different future projections. Some are warmer, some are, most are warmer, almost all are warmer, but in different ways. And some are wetter, some are drier. We think that there should be more precipitation variability, right? So warmer, or rather drier dry periods and wetter wet periods. And that should affect fire regimes in some places. So it really, I mean, I hate to use the "it depends," but it really does depend.
Thank you for that. I'll move to another related question. And what do you think? And probably Tom, you might be best suited to answer this, but as I said before, everyone else can chime in. What is the projected change in fire season length for Southern California? So now we're more specific on our state. And how do you think it will be different from the projected scenario for the northern portion of the state?
Great question. I don't know if I have answers to all of that, but let me take a stab at it, and then hopefully others can join in. So, and again, it depends on, as Max pointed out, the the different projections from our models. Depending on what climate model you use, you're going to get some different results for sure. Certainly, there's we do see, in terms of precipitation, the potential for more variable precipitation across, at least across Southern California. So in other words, more extremes in precipitation. It's, when we take a look at one of the major drivers for ERC is going to be temperature. And when we look at the projections for, for temperature, we have a high degree of confidence that we'll continue to see warming throughout the region. And so that would imply that the energy release component would be higher maybe throughout the year, and even but more so in the in the peak of of summertime conditions, right? So that would suggest that we would see potential to see more extreme fire behavior with higher energy release component values in the summer, when we see really our fuel-driven fires, sort of our season for fuel-driven fire activity. But then, the startup time in the spring, and then the ending time of our fire season in the fall is really going to be dependent on those, on our precipitation events, which again, in Southern California, I don't think there's a real clear signal in terms of, trending drier or I mean, there is a signal of trending drier, but again, those more certainty around having extreme events, longer periods of drought, and then these high precipitation events. When you get into Northern California, there is looking like the potential for a little wetter conditions going into the future. So it's really, that's a tough question to answer, and I don't really have a clear answer. I can't say definitively, oh, well, this is going to happen based upon our future climate predictions. What I can say is that I think in Southern California, I would lean more towards Southern California having longer fire seasons. I mean, certainly that has been the trend. Even if you didn't look at the data, just sort of, just thinking about your memory of, over the course of the last few decades, certainly fire season seems to be getting longer, and I think that's true in the data. But so I would lean in that direction. But in terms of the rest of the state, I think it's a little bit hard to determine. So anyway, I'll stop there, see if anybody else has anything to add.
I'll give someone a moment if anyone wants to add to that.
Yeah.
Okay, go ahead, Rong.
Oh, this is really a question, not answer. Is we're primarily now consider temperature when we look at a fire season, but what about like combination of a temperature and the humidity condition, for example, as indicated by drought index, which is combined? How would that affect fire season length?
Well, certainly the combination of the two is what's driving, our fire season length for sure. No doubt about it. I think there's, you pointed out, the changes in vapor pressure deficit, over the course of the last several decades. And, we see those projections of, in the future climate, using the different climate models. So again, I would lean towards Southern California seeing longer fire seasons, because I think both vapor pressure deficit and temperature projections support that. But again, it's not like every single year is going to be, worse than the last year, right? You're going to have a lot of variability. I think generally speaking, the overall trend would be for longer fire seasons in the southern part of the state. I think the northern part of the state, I don't think we have a real clear signal. But again, I just want to emphasize that I don't think every year is going to be worse than the previous year. There's going to be some years. You look at 2019, extremely quiet year for fire activity across really the entire state of California. So there's going to be a number of those years mixed in. So anyway, just want to highlight that.
Okay, thank you both. I want to shift to another. It's related, as all of these presentations have been, but a slightly different focus. And what are the main negative implications for both wildlife and ecosystem services to humans of having a high abundance of non-native grassland species in some watersheds across California, especially in regard to a change in the risk of wildfires? Now, Max might be best suited to start off answering that question.
Well, I'll give it just a very short response and then hand it off. That there's no question. I think there's broad agreement that invasive annual weedy species in Southern California can lead to easier ignitions and more frequent fires in the shrub communities, which really aren't adapted to frequent fires, right? And then you have sort of a feedback effect that continues and starts to expand that process across the landscape. Then I would probably hand it off to Wallace, I think.
Yeah, so I think that if we're looking at the effects on biodiversity on these fires, when we have type conversion or we have these disturbances, the organisms that require, say, California sage scrub or chaparral for their survival are going to be impacted. And when we have type conversion, we're going to lose them from the landscape, or at least in those local areas. So there's quite a few species. Like when we're doing comparisons in areas, there's quite a significant number of species require, for instance, sage scrub for their survival, or are found only in sage scrub and not in the adjacent non-native grasslands in these habitats. So, I mean, I feel like what it suggests is that fire is contributing to or can significantly contribute to biodiversity loss within our region, and it's a major concern.
Okay, thank you. And a related question, and one that that I know many people are interested in, is at the watershed level, how can local communities contribute to or to most significantly mitigate climate change impacts now in order to reduce the threat of more devastating wildfires in the coming years? This, I think, is a question that maybe each of you can take a stab at answering.
I'm sorry, Marilyn, can you repeat the question? On my end, it was your voice was a little jumbled.
Sorry. At the watershed level, how can local communities contribute to most significantly mitigate climate change impacts now in order to reduce the threat of more devastating wildfires in the coming years.
Thank you.
Don't all rush it.
Well, I'll say a few words. I think that's a super important but really difficult question. I think most at the watershed scale, at the larger scale, we have tools in our toolkit include things like community wildfire protection plans, but they generally focus on fuel break placement and prioritization, and not as much on, say, greenhouse gas emissions and so forth. So we probably need something that we don't currently have, which is a framework for integrating a lot of those concerns and ecosystem services into the prioritization, siting and design of fuel breaks and other community safety activities that we could be undertaking. If anybody wants to get in touch, I have a lot of ideas on that, but no simple answer. I'd love to hear anybody else that has a simple answer. I don't think there is one.
Yeah, I don't have a simple answer by any means either, but I will say that I think being Californians and being residents in California, I think we're going to have to take a really holistic approach to thinking about fire, and not just thinking about fire myopically, thinking about water, right? Like, how do we preserve water? How do we preserve biodiversity in this biodiversity hotspot? How can we really combat like some of societal's biggest issues simultaneously? Like, so how do they all interact with one another? So thinking about how we can maybe re-landscape to use less water, but also store carbon, and start thinking about what plants actually take carbon out of the atmosphere and put it into the soil at a higher level, and focusing on research that does this, and also, which native plants do this that actually support biodiversity even within our suburban urban landscapes. So taking a holistic approach to these types of questions, and is going to involve a lot of different people interacting with one another, and hopefully that we can move these questions forward.
Yeah, I would like to follow up with Wallace's comments, and also Max. I really feel the holistic approach is very important. For example, during the recovering of drought, probably fire too, that what kind of a plant is really important for actually recover of the runoff and the stream flow. So when we're thinking about how community could mitigate the impact of fire on biodiversity, on future fire load, I feel perhaps on the water resource, that's also very important, because when I was in Texas, I know they introduced plants to really prevent erosion of the riverbank. It turned out to be these plants are so thirsty, and they just suck all the water from soil, and so leave very little water runoff to feed the stream and for reservoir recovery after drought or fire.
Okay, thank you. Thank you for those responses. Switching a little again, what do you think? And this, I think, is something that can be answered by all of you. But one question is, what do you think the main scientific challenges or the main data gaps exist in advancing our knowledge to help predict the link or the feedbacks between the atmospheric conditions and the occurrence of wildfires?
I can get started just from the drought point of view. So when we are looking at compounding effect between drought, fire, and heat wave, a first challenge is we don't really have data that actually integrate across these three different broad area. And that's the first thing you can, if you don't have data, it's kind of hard to understand what's going on. That's one challenge right there. We could address by just being coordinate among different communities, research communities, and observation, and also getting data from stakeholder as well.
I'll just jump in here. From my perspective, I think there's so much we still don't understand about, the connection with drought and wildfire. For instance, if you consider the drought we had in the early 2000 teens, really the first few years of that drought, at least across Southern California, there wasn't, that was really followed by a few fire seasons that were relatively quiet across the region. And then it wasn't until around 2016 or so that we started to see an increase in larger fires, at least across the southern and central portions of the state. But the drought had already been in progress for a number of years prior to that. So the question is, why is there a lag there? And is there always a lag when we see significant drought? If you think about what's going on this year, why is Southern California so relatively quiet in terms of fire activity versus the northern part of the state, where it's been they've had some of the worst conditions in recent years? So there's a lot of unanswered questions there. I certainly we may contribute it to the lack of grass crop that occurred in the spring just due to the lack of precipitation in the winter. But is that really telling the whole story? I'm not sure. I think there's, again, just a lot of unanswered questions and a lot more research that needs to be done in sort of putting these pieces together and making the connections, connecting the dots.
Thank you for that. Max, you unmuted. Were you going to?
Oh, I was just going to pile on in agreement that, yeah, there are some unanswered questions that are really important. A lot of this climate variability has to go through the plants, right? It has to go through the soil and then through the plants in terms of fuel moistures, at least in part, for this all to actually manifest in terms of flammability and fire activity and sizes of fires and so on. So there are some really, really important unanswered questions there. I think for the future, one of the things that we all need and have somewhat limited confidence in are the projections from the climate models about interannual variability, right? Many of the modeling attempts for fire anyway have been built on longer term climate norms, right? So 25 or 30 year climate norms for whatever variable you're interested in. And we know that fire responds to interannual year to year fluctuations in those same variables, but we have less confidence about the how frequently a drought year follows a bad fire year, which follows a bad a high temperature year, right? The sequencing of these future years is really important from a fire and then from a regrowth, a regeneration perspective. It's much different if you have a fire year followed by a drought year than a fire year followed by a good rainfall year, right? Those are really different from the recovery perspectives, and I don't think we have very good confidence in the climate projections on those interannual variability values, which would be really helpful. That's a big unknown too.
Yeah, let me, sorry, go ahead, Wallace. And then I just want to add a couple more things.
Okay, great. So yeah, maybe you can add on to what I'm about to say too. So I think it is really interesting to think about the interaction between drought, grass growth, and ignitions, right? So so this is something that I think we could talk about. So during the drought, like the grass is not going to grow as much. There might not be as much fuel in these interstitial spaces to spread fire. It might lower ignition probabilities. So it might be counter to what most people think, that during a drought, fire probabilities in Southern California, at least, are lower. Now in Northern California, the fuel loads that are built up, they get drier, it's going to increase ignition probabilities in big fires. So this is the difference between Southern California and Northern California. So I think looking at those interactions are intriguing. I think one thing that's also intriguing is predicting what ignitions will be like in the future. Can we talk to people like, when your car is overheating, don't pull it off on the side into the dead grass, right? That these grasses are really fueling these ignitions. Can we build the eco-literacy of the general public? And could this feed back to reduce ignitions in Southern California and potentially reduce fire? I don't know if that's possible, but maybe.
Yeah, and the other thing I was just going to add is and this is just sort of just for discussion, really, not really answering a question, but it's really interesting when you look at precipitation, particularly across Southern and maybe to a lesser degree across Northern California, but across Southern California, when we look at average precipitation, that statistic is almost meaningless because of the high degree of variability that we see from year to year across Southern California. And so it's really difficult to sort of establish an average across the southern part of the state and how that relates to fire activity, just because of the high degree of variability. And and the other thing too is that it's really in Southern California, it's hard to get consecutive years, beyond maybe 2 of really wet years across Southern California. Usually we get really like one big really wet year, and then it's followed by a number of drier years, and then we'll get another wet year. So it's just, again, it just sort of makes those connections to relating to wildfire activity difficult, just because of the extreme variability we see in precipitation from year to year.
Thank you very much. In answering that question, you've unknowingly answered about 2 or 3 others that I had in the lineup, which is really good. I see, Eileen, you have your hand up.
I do, because I'm fascinated by the conversation that started, and certainly the presenters have given us a lot of really good information, but I'm here to kind of just remind us that we're short on time, and I'm here to transition us out of this panel to the next panel. So Marilyn, I'd want to offer you just some opportunity to kind of wrap up your thoughts of what you've heard, and then I'll take it from here and move us into the next panel.
Well, okay, I'll be brief. First, let me thank the panelists for really fascinating presentations. Wildfire is not my primary area of research or even secondary, and I've learned a lot. You've answered a lot of questions. One of the things I realize more and more is that focusing on wildfire in California is something that we're going to have to be continuing doing, because it is quite clear that we're going to have increasing frequency of fires and increasing severity of fires. Saying this right now and listening to the news, you can see those comments line up, right? How we deal with those fires is going to be important, both at the community level and at the higher levels in the administration, federal and local and state levels. And I'm really happy that we have scientists like you to help us navigate our way through the upcoming years.
Thank you, Marilyn. Thank you, Rong. Thank you, Wallace. Thank you, Max. Thank you, Tom. It's been great having you. Note that there are a number of questions in the Q&A feature, and if you can spend some time answering those questions, that'll help us kind of follow up on our promise to get more information out there to our audience. And I know we're always short on time with our symposium sessions, and it's not, it's just, we said we were going to have a full program. We have a full program, but we want to consider this as a start to that conversation, start to many conversations and dialogues that we need to be having. And I'm wanting us to move into the next panel to kind of continue on to build off of what you've provided us with, a really great and solid foundation of some understanding of frequency and the feedback loops and the gaps in the research that we need to be thinking about. So Thank you all. I hope you are able to stay with us through the entire day, and certainly come back and we'll do some follow-up with you. For now, I'm going to come back to sharing my screen to get us to the next session. Let's see. Hopefully my screen is being shared. I don't have any feedback on that. Let's see how I'm going to go forward. Give me a moment. Get my orientation here. But our first panel definitely gave us a lot of food for thought. There's a lot of information packed into those presentations, and the dialogue certainly gets us going into our next panel. And so with that, I'm going to welcome back Sabrina, who is going to take us into our next panel. And I'll come back in around 5 minutes before we have to wrap up. Sabrina, are you good to take us into the next panel?
Absolutely.
Great. Move that forward.
Before we do that, I just want to reiterate what Eileen had said about the Q&A. We haven't had time to get to all of your questions today. We will try to follow up with the speakers and, of course, panelists from the first panel. We'd love to hear you, or we'd love to have you answer those questions as well. And I've answered some where I feel that they were within my field of expertise. Okay, so I am really excited today to kind of move the conversation into something that certainly came up in the Q&A from the last panel, which is, you know, how are these climatic impacts to weather and these weather impacts to fire actually affecting a lot of the natural resources and human resources that are important to communities. And we're going to start today. I'm going to introduce all the speakers, by the way, Dawn first. But we're going to start today with Dawn Petschauer. Please correct me if I mispronounced your last name.
Petschauer, like
Petschauer.
pet and shower. It's a tough one though.
Okay, and she's the senior water biologist with the city of LA. And she's going to be giving a presentation that also includes some input from Matt Rich from Wood Environmental and Infrastructure Solutions and Brianna Dottie from Craft Water Engineering. After Dawn, we're going to hear from Toby O'Gene, who is a soil resource specialist in cooperative extension and at UC Davis. So he's one of my colleagues in UC Ag and Natural Resources. And he'll be talking some more about soil issues. And then we're going to hear from Sterling Klippel, principal engineer with LA County Public Works. After that, Jeremy Lancaster with the California Geological Survey will be speaking some more about sort of watershed impacts of fire. And then we'll have Scott Epstein with South Coast Air Quality Management District. And finally, Julia Van Soelen Kim will be wrapping us up today, kind of bringing it home to talk about how fire is impacting food resources. So Dawn, take it away.
I will. Thank you so much. Good morning, everybody. As mentioned, my name is Dawn Petschauer. I'm with LA Sanitation. I'm actually here with Matt on behalf of the Upper LA River Watershed Management Group, or the ULAR WMG, to discuss a case study we're pursuing that's looking at the impacts of wildfire on water quality in the LA region. Next slide, please. There we go. So to give you some context of who we are and where we are the largest group of stormwater managers in the LA region. We've got 19 participating agencies. I think you might have to click. I think there's some animations in there that aren't popping up. There we go. 19 agencies across 500 square miles of mixed land uses and topography. So we have some open space and forest upstream, and then we move quickly into a highly urbanized and densely residential corridor downstream. In total, our group covers 31.5 miles of the LA River. That's 5 of the 6 segments, 11 tributaries, 3 urban lakes, all with varying conditions, including soft bottom sediments and concrete lined channels. Next slide, please. So the animations aren't showing up here either. You might have to click. Not sure what's going on, but yes, across these receiving waters, we have 62 impaired water body segments, plus individual lake impairments. So we have multiple TMDLs, which are shown on a timeline that is not visible. Maybe one more click, there it is. With a wide range of pollutants that need to be addressed. And under our current watershed management program that was developed by the group to address all of these water quality issues, the initial cost projection was just over $6 billion, which is far outside what the agencies can afford under our specified timeline. Next slide, please. So in addition to these collective challenges, wildfires, as we know, have increased in frequency and intensity within and surrounding our watershed management area. Previous research has documented that wildfires produce various sources of post-fire pollutants, including gases, aerial deposited particulates, fire retardants, sediments, and ash. Watersheds that have been afflicted by wildfires may drain to rivers, lakes, and streams that are already designated as impaired, often for the same parameters that are found in post-fire runoff. And as you can see from this chart down here, an increase in concentrations of nutrients and metals in surface water have specifically been documented anywhere from 4 up to 921 times higher than open space areas post-fire. And these are of key importance for the ULAR watershed due to our existing impairments. Next slide, please. So with this information and our regulatory requirements, the ULAR group elected to pursue a fire effect study through the Safe Clean Water Program, which is Measure W, photo approved in 2019, to specifically understand the impacts of wildfires on water quality in our region. Ultimately, our goal is to create a more resilient watershed management program that achieves TMDL compliance by assessing the best strategies to improve water quality under fire impacted conditions. So this includes informing the community on the impacts of wildfires on water quality and creating post-fire numeric goals that are still protective of the beneficial uses in our receiving waters. In addition, we want to predict the impacts on water quality from future wildfires and other climate change scenarios and know what this means in terms of BMP performance that we are putting into our watersheds. Next slide, please. So as this is the first comprehensive fire effects study in the region that we are aware of, we understand that the study design must work in unison with existing and planned efforts, both state and regionally across the region. So we've been actively researching and reviewing previous studies for applicable historical information and working closely with current research on the bioavailability of metals, such as the biotic ligand model. This information will essentially feed into our final design approach, which will identify key data gaps in existing regional data and develop rapid response monitoring plans and tools for current and new wildfires. The modeling focus will take the monitoring data compiled, including historic and more recent data collected, and will characterize the post-fire landscape and take a look at how land use and other environmental changes resulting from fire impacts the typical baseline pollutant loadings in our watershed. In addition, the modeling will incorporate a range of climate change scenarios, which have the potential to further exacerbate the fire impacts. And it'll be available on the ULAR website for use and serve as a template for other regions as well. We've already presented the approach and intent of the study to the LA Regional Board, and it was well received, and we'll continue to collaborate with the board and technical advisors at key steps moving forward. Next slide, please. Oh, one last one. There should have been one more, but that's okay. We were just going to say that our regional collaboration is a core piece given the challenges that the entire region is facing with increasing wildfires and really understanding what that means with respect to our collective water quality. So just to give you some information on our coordination to date, in addition to the 19 agencies in the ULAR group, we have been supported by the San Gabriel Valley Council of Governments. They're actually a co-applicant of ours. So this includes 8 other non-Upper LA River cities, 1 sanitation district, 1 water master, 2 municipal water districts, and of course their water policy technical advisory committee. We've also had interest from members of the Rio Hondo and the San Gabriel River watershed management groups. And we already coordinated with the San Gabriel Regional Monitoring Program, who actually conducted a similar study for the Bobcat Fire, leveraging the same monitoring program outlined for this one. And then our recent efforts include coordinating data sharing with SCORP, as well as Ventura, Orange, and Riverside counties. This will allow us to build a robust and expansive data set to reference and expand through this efforts. And in addition, we know that there are ongoing statewide efforts to better understand and strategically address the growing impacts of fires across California that we plan to coordinate with. And of course, we'd love to find additional engagement with everyone here as well. So with that, I will pass it back and look forward to answering any questions about our study in the panel discussion.
Thank you so much, Dawn, and sorry about the slide removal. I sort of moved it to something we can discuss more in the discussion.
Sure.
For all the presentations. So our next speaker, I'm going to hand it over to Toby O'Gene to talk about the impact of fire on soil systems.
All right, great. Thank you.
Are you able to turn your camera on, Toby?
Oh, sorry. I thought I was automatically on. Oop. Come on. How's that?
Great, thank you.
All right, thanks for inviting me. My expertise in soils focuses on the stratigraphy and geography of soils and how that understanding can help us with agricultural decision making, solving environmental problems, and understanding ecological relationships. And a big focus of my program that leads to that end is in delivering soil survey information. And some of these snippets on the bottom of the slide can show you our soil web products, which are essentially making soil survey more usable and informative to the public. So if you'd like to learn more about soil, I'd encourage you to go to our website or simply Google California Soil Resource Lab, and you can find some of these tools that can help you make decisions about soils in the future. So next slide. What I'm going to do today is just try to give you a 7-minute primer on the effects of fire on soil. And I'll start by saying they're varied. There's lots of impacts of fire on soil, but we can kind of nicely address it or learn about it by considering the litter layer of soil. That's kind of like a protective blanket that coats wildland soils, and it has a lot of ecological important benefits to soil. It acts like a slow release nutrient supply as microbes decompose that plant detritus. They slow release fertilizers that are, slow release nutrients that plants can consume. It's a protective cover against erosion. It protects the soil from compaction. It also serves as a mulch, preventing evaporative water loss from soil. It's the food source for microbes, and it's really a big part of the soil carbon pool in wildland soils. And it promotes high infiltration rates when water is being absorbed from when soil is absorbing rainfall. So it's really important from the hydrologic perspective, the carbon cycling perspective, and nutrient cycling perspective. And it's essential for healthy soils. And this is, if you were to summarize the effect of fire on soil, it's really a result of how much of that layer is consumed by fire. So when we have catastrophic fire, that layer can be completely consumed, and that has some pretty severe impacts on soil. It creates large pulses of available nutrients and naturally occurring elements like heavy metals. Those nutrients could be volatilized and lost, or they could be liberated and leached from the system. We have now no cover on the soil surface, and that accelerates erosion. We see that runoff is greatly accelerated. We see a drastic reduction in microbial biomass because if the fire is very intense, the microbes are killed. And then we also see some positive benefits in that we see an increase in recalcitrant carbon that doesn't decompose, and that's called black carbon. So next slide, please. The impacts, as I mentioned, are varied. Those outcomes depend on the fire severity, how hot the fire is, and how long it burns. And that's a function of a lot of things, mainly fuels. But if we were to focus on low temperature fires, first of all, we can see that there are some benefits of low temperature fires. They maintain a protective litter cover. These pictures in the bottom here show some slight alteration of the litter layer, but most of it is intact. the temperatures are not hot enough to destroy the microbial populations in soil. Usually in a low severity fire or moderate severity fire, only the top few centimeters of soil witness extreme temperatures, so the microbes are able to survive. Many of you have heard there's over 1 billion microbes in a teaspoon of soil, and all those microbes have different jobs, very important ecological jobs. So we want to keep them alive and happy. Low temperature fires stimulate nitrogen or nutrient releases, but they don't necessarily volatilize a lot of those nutrients. So it's a way to rapidly fertilize the forest. And at the same time, it doesn't alter the organic matter so significantly so that we can still absorb the nutrients and not lose them to leaching. And it also maintains a hydrologic health to the soil with some short-term water repellency, which I'll talk about in the next slide. So how do catastrophic fires harm soil? I will say that catastrophic fires are harmful to soils. First of all, a lot of times they create water repellent soils. So what happens is the intense heat volatilizes waxes and resins in vegetation and litter, and that vapor goes down into the soil, coating soil particles, making them water repellent. And then as rain falls on the soil later, it infiltrates in the soil, but hits that water repellent layer, supersaturating all the soil above, which gives rise to some of these mudslides and debris flows that we see over time in relation to other things too. That complete loss of soil cover makes the soil susceptible to raindrop impact. And that's the first step in erosion. You have to detach particles from soil. Soil is aggregated into clumps. Those clumps are hard to move, but when those clumps or aggregates are destroyed by raindrops, those tiny particles can be mobilized and eroded away. Similarly, point 3, the aggregate stability. When particles are aggregated together into clumps or structure, they're able to withstand the forces of erosion. They act like larger particles and they're harder to move. But those aggregates can be more delicate after catastrophic fire, and that makes soils more prone to erosion. The macro porosity of soils is diminished. The large pore space in soil decreases. It gets clogged with ash and fine particles. That slows infiltration rates, giving rise to high runoff and therefore erosion. There's also reduced evapotranspiration. When we destroy all that vegetation, evapotranspiration rates go way down. That means in some settings, our soils become super saturated with water in the wintertime. And that is when our soils are least cohesive and most prone to failure or landslides. Also, when supersaturated nutrients and available metals are subject to leaching and loss. The roots are destroyed, roots anchor soil, that gives rise to erosion and landslides. As I mentioned, some nutrients are volatilized and lost and the microbes are destroyed. And finally, nutrients that are available with fire, we diminish the soil's capacity to hold on to those nutrients in exchangeable ways. So those nutrients are just much more free to move with the water, and as water moves either laterally or vertically, they're lost from the soil. All of this gives rise to a site degradation, right? As we get this negative, or I guess a positive feedback loop of negative outcomes, the soils become less healthy, less able to support plant life, and more erosive over time, and that creates a problem. So next slide, final slide. The problem is that there's not a lot of solutions. Once you have a catastrophic fire, it's hard to fix the soil, mainly because of the vast acreages that they encompass. So really the way forward in terms of protecting our soils from catastrophic fire or improving soil health in this instance is to protect and limit the amount or degree of catastrophic fire. And so I just wanted to end with this slide summarizing a project that I'm involved with. It's a multi-institution project funded by the Strategic Growth Council, where we're trying to incentivize this ecological forest management concept that Jessica mentioned earlier this morning. $1.5 billion is a lot of money, but it's not going to be enough to treat our vast California landscapes. And really what we need to do is we need to reduce the amount of vegetation in an ecological way so that we don't have these catastrophic fires. And so we need more partners to do this, and we need to incentivize the partners to contribute to this ecological management of our vegetation in California. And that means we need to develop data sets so that people understand water availability and how we can treat forests to improve water supply, reduce wildfire probability, protect carbon stocks, and improve forest health. Thank you.
Thank you so much, Toby. I'm afraid I looked at the wrong page right here. I was busy answering questions. Sterling is going to talk to us now a bit more about specifically about how to manage debris flows. Sterling.
Good morning, everyone. I'm Sterling Klippel, and I'm very excited to be here as part of a panelist today. I'm a principal engineer at LA County Public Works, and I oversee the operations of 14 major dams and 27 spreading grounds for both flood management and stormwater capture and groundwater recharge for local water supply. I also manage the development and implementation of flood control infrastructure projects, and I also direct the post-fire engineering activities that include analyzing burned watersheds for debris potential, implementing temporary debris structures, and also working with the local communities of measures that can be taken to help protect homes from debris flows. So with that, today I'm going to briefly present on our post-fire infrastructure and the mitigation measures that we work on after fire. So here, as the LA County Flood Control District, which is administered by Public Works, we own and operate a very complex water conservation and flood management system. It's a very integrated system. Everything that happens up in the mountains at the dams has an impact on our downstream facilities through the urban areas. So we have 14 major dams, 162 debris basins. They're typically on the smaller watersheds. And then we have 500 miles of open channels, and again, 27 spreading grounds. This picture here was recently taken here in February of this year. This is after a storm that occurred over the watershed for our Santa Anita Dam. And this watershed was burned by the Bobcat fire. And as you can see, there's a lot of debris, mud, and silts that were captured behind this dam. And that really is one of the major functions of our dams, is not only to capture stormwater for water supply, but also to hold back these massive debris flows that come down out of the San Gabriel Mountains. And they're part of their operation is hold back all that debris and then allow the stormwater to continue downstream through the system. Next slide, please. So as I mentioned, we also have debris dams and basins. These again will hold back all the debris and allow the stormwater to continue downstream. This is at our Lower Sunset Debris Dam. This picture was taken by me in January of 2018 after we had a high intensity storm over a smaller watershed. But as you can see, again, a lot of debris, mud, silts, sediment that were captured behind this and are later cleaned out. If you look closely, you could see a Toyota 4Runner that was also washed into this debris flow. There it is right there. And then maybe a trash can just to get an idea of the size of the basin. Okay, next slide, please. So first thing after a fire, we send out our engineering teams to conduct reconnaissance once it's safe to do so. And they'll actually go out and verify the perimeters of the fires for every fire that occurs in LA County. And then we take that back and we overlay it with our sub-area watersheds, and then ultimately calculate debris flow potential out of each of these different sub-areas within the watershed. And then we go a step further, and then we want, based on that amount of sediment in the debris flows, we analyze where that debris is likely to end up in relation to structures and other infrastructure downstream, as you could see on the map on the right-hand side there. The different colors show the different amounts of debris that we'd expect, and where that debris would ultimately settle out. Next slide, please. So here, after these fires, and we do all the mapping, we also do the reconnaissance. In the upper left-hand corner, you could see this burned smaller canyon here, and it's directly focused on some downstream homes. So we'll go home to home and offer post-fire engineering advice to the homeowners on measures that they could implement to help protect their homes and, keep this mud and debris from, ultimately impacting their houses. In the lower left-hand corner, you can see here where we've gone out, we've worked with the homeowner, and they've implemented some sandbags here to help divert the debris flow from going into their living room and around the houses and actually out to the street below. And then in the upper right-hand corner here's kind of a historic picture of debris flow that occurred in 1934. It damaged 500 homes, and miles away from the mountains, you could see in these pictures these huge boulders that were washed down as part of this debris flow. And then a more current debris flow here following the station fire in January of 2010 in the La Cañada area, a home that was wiped out from debris flows. Next slide, please. So here, again, we track all the fires in LA County. Here's a listing of 17 fires. Typically, we say that watersheds take approximately 5 years to recover. There's a lot of different factors that go into exactly how long it takes to recover. But each of these fires here, we've gone out, we've evaluated it for debris flow potential and potential impacts to homes and access to those homes. In other words, streets and highways and things. And based on that, we, depending on the watershed conditions and weather forecasts, it could lead to actually evacuating some of these communities that could be seriously impacted by these debris flows. So as always, we say, debris flows are highly unpredictable. It's really a lot of factors go into it. I know in Toby's presentation, he mentioned saturated watersheds. So that's part of the watershed conditions that we monitor, and what kind of storm events as far as rainfall intensities that will trigger these debris flows. But depending on all those and looking at that, we'll issue actual debris flow forecasts. So if we do, based on our look at the different conditions, if there is a strong potential for a debris flow, we'll notify the communities, and we'll work with local agencies and first responders to actually evacuate people if we feel that there is the potential for some devastating debris flows that could impact houses. And so we monitor these closely, all the different watersheds for up to 5 years. So in closing, just want to say Public Works is very committed to flood management, healthy watersheds, and protecting communities from debris flows, both from a large scale perspective with flood control infrastructure, and then down to kind of the micro scale where we'll actually have engineering teams go home to home and work with the homeowners to implement measures to help protect their houses. very passionate about the work we do. And again, happy to share our mission and the work that we do to mitigate these debris flows for the communities downstream.
Sterling, thank you so much. Yeah, you guys have a hard job. That's for sure. Okay, we're going to move on to Jeremy, who's going to be talking about sort of a similar theme at a larger scale.
Great, thank you, Sabrina. Can you hear me?
Yes.
Awesome. Okay, so yes, I manage the California Geological Survey's geologic and landslide mapping program. I've worked on wildfires for about 15 years, doing debris flow mitigation for California communities, monitoring burn watersheds, worked on the Thomas Fire and the Montecito disaster. So that's kind of my background. But I'm going to talk about, really give you an overview of some statewide products developed by the California Silver Jackets to help California communities affected by wildfire be prepared and ready. And so who are the Silver Jackets? Obviously, I'm not wearing a silver jacket, but the Silver Jackets is a consortium of federal, state, local, and NGO organizations that come together prior to disaster to plan, prepare studies and tools that California communities can use in response to mostly flood and flood after fire type disasters. So next slide, please. So I'm going to talk about two products from the Silver Jackets team. Primarily, the primary product here is an after wildfire guide for California communities. This guide is a compendium of resources developed to support California communities in recovery efforts after wildfire, right? So you have a wildfire, which is its own disaster, but then you also have a watershed emergency after wildfire. And the document really provides, just the practical guidance about your personal safety, right? And when I say safety, I'm talking about, you have a burned watershed, you have hazard trees, right? You have trees that are burned with the potential for falling on homes, cars, across roadways. You have the potential for flash floods, debris flows, rock falls, landslides. And so this document kind of gets you prepared, because the hazard is not over after the wildfire. You're going into a second phase that you need to be aware of, and so that helps with public assistance, managing your financial funding aspects, mobilizing your community, and there's a document linked down below, but the document is also linked in the Watershed Health 101 page that was put in the chat earlier. All right, next page or next slide, please. And the second product by the Silver Jackets team, I'll talk a little bit more about. This is the Flood After Fire Toolkit, and this is a document that really highlights the technical sort of phases of pre-wildfire, during a wildfire, the technical needs for responding to watershed emergencies, pre-wildfire, during wildfire, and post-wildfire. And so the publication really provides resources for technical folks. So I'm talking about engineers, floodplain managers, hydrologists, soil scientists, geohazard specialists, but it can also serve as kind of a playbook for local emergency managers to sort of understand the process and the products that are prepared by things like the federal burn area emergency response teams, or maybe the Army Corps is going to come in and do a floodplain study within an area that was burned or area downstream of a burned watershed. So this document, it serves a couple purposes, but it's a little on the technical side. Really, again, those primary time buckets of being prepared before a wildfire, what you do during, what resources are available after, and then how to share data after a wildfire response, emergency watershed response. So next slide, please. So this is really the layout of the toolkit. It covers concepts, procedures, products in time buckets. And I think I mentioned this already, but there's really a pre-fire planning phase, a time tier 1, which is a fire begins prior to containment. How do you prepare? How do you prepare your technical resources? Time tier 2, which is 1 to 2 months after fire containment. How to prepare and deploy technical resources, and then time tier 3, which are like longer term floodplain studies within and downstream of the burned watershed. And the details here are really, from a pre-fire planning perspective, providing the user of the guide an understanding of what, like GIS data, spatial data, should be collected during the off season prior to an event that would be used for assessment analysis during an event. What cartographic products are typically prepared, what field applications could be prepared in advance of a wildfire, so that when you're deploying field teams, you have that as a resource in your back pocket. What data you would need to pull together for hydrology and hydraulics sorts of investigations, like flood modeling. And then in the second tier is really, you've had a wildfire, it's prior to containment. It speaks to bear teams, which are really federal watershed emergency response teams, and then state watershed emergency response teams, which are the work teams, and what GIS data they bring to the table, what they use for assessing burned watersheds, and what products they provide to the local communities that would help them understand values at risk within and downstream of the burned watershed. And there's other tools there. And then really the time tier 2 is the fire's been contained, the bear and work teams have done their assessments. What in the short term, what hydrology and hydraulics data needs to be pulled together for sort of rapid modeling assessments, and what products could be prepared and what are the deliverables. And then really time tier 3 is a more robust treatment of the GIS data, modeling tools, and sort of the longer term analysis and reports that go into watersheds. You can go to the next slide, that's fine. And then to support those timelines, we've developed a series of appendices to the Flood After Fire Toolkit, which are a series of tables, and we call them matrices, but there are 4 of them. There's an agency resource timeline matrix, which really talks about those different time buckets, those different time tiers, what's done, who are the stakeholders, who are the parties that need to know the information. And it's kind of a crosswalk to help someone like an emergency manager or a floodplain manager who has never had a wildfire in their in their area, to sort of understand what resources are coming in and who are the contacts. There's a GIS spatial data matrix, talks about data formats and categories, and then H&H model matrix that really steps through about 25 different models that can be used to assess runoff debris flow hazards after a wildfires occurred in a watershed, and those vary from very simple models to very complex models, and then also a products output matrix. So that is essentially it. Those two documents are posted on the website, and I'm just going to plug the two California Silver Jackets leads, which are Rachel Oriana from the U.S. Army Corps of Engineers in Sacramento, and then California DWR is really the co-lead, Christopher Williams, in Sacramento as well. And we, on an annual cycle, we come together, we do annual meetings with the Floodplain Management Association in September every year, and we brainstorm on topics that could become studies for California communities. And so I put their names here and their emails. Feel free to email them if you have ideas for Silver Jackets projects. And with that, I thank you.
Thank you so much, Jeremy. And I'm excited to be working with Rachel and other folks on the core side of the Silver Jackets team. We're trying to develop some scenario-based training to increase the capacity for communities to be using that toolkit. All right, we're going to shift gears a little bit from water and soils to air and hear from Sterling. I'm sorry, hear from Scott. I'm so sorry.
Good morning, everyone. My name is Scott Epstein. I'm the program supervisor of the Air Quality Assessment Group at the South Coast Air Quality Management District. So we're the regional governmental agency that's responsible for regulating air quality in major portions of the 4-county area. So that's LA, Riverside, San Bernardino, and Orange County. So I have this short presentation that summarizes our efforts to help people reduce their exposure to poor air quality caused by wildfires. The background here, if you haven't noticed it yet, is the Bobcat, which is in the center of the screen, and the El Dorado fires on the 9th of September, so a little over a year ago. Next slide, please. So how do wildfires influence air quality? So if you live in the West, which I assume most of you do, you've probably experienced this firsthand. Your lungs have also experienced it firsthand. So this plot shows fine particulate matter, which is the main component of wildfire smoke, for each day of 2020 in LA County. So from January till the end of December. So I'm plotting the air quality index. So this is a method we use to communicate the health risk and recommend actions for varying PM 2.5 concentrations. We use it for other pollutants too as well, but this plot is just focusing on the air quality index from PM 2.5. So the 2020 values are shown in black, and then the 5-year average values are shown in the faint gray line kind of behind that black line. So typically our highest PM 2.5 values are recorded in the winter, and then things tend to be much cleaner in the spring, fall, and summer, assuming there's no wildfire influence. So it's pretty easy to pull out a few of the major fires that affected our region in 2020. On several occasions, we reached unhealthy, which is red, air quality index levels. And this is a topic for another conversation, but the highest peak in the center of the screen is actually due to Independence Day fireworks. Next slide, please. Great. So exposure to smoke is associated with a wide variety of health effects. So many people associate smoke with respiratory effects, but the cardiovascular effects are also a major issue. And then studies show that smoke can possibly harm the developing fetus. And then there have also been a lot of studies looking at exposure to all types of PM 2.5, not only smoke, and they show an association with lung cancer, with cognitive decline, and an increased susceptibility to respiratory viruses, which is particularly important in the middle of a global pandemic. Next slide, please. So how do we help people reduce their exposure to poor air quality from wildfires? So what we did is we developed a state-of-the-art air quality index map that blends data from our regulatory monitors. These are these official maintained monitors, hundreds of low-cost sensors that we deploy, and also just citizen science sensors, and an air quality model. And we blend this data. We have this map on our website and also on the South Coast AQMD app. And we've shown that this map is more accurate than previous methods, and it especially shines during wildfires. The app allows users to pick their favorite locations, maybe their home or their work or their relatives' place. And it can also send automatic notifications to these selected locations during periods of poor air quality. And when we designed these products, we made really sure to provide the guidance for the precautions that people should take at each air quality index level to make that very easy to access. So we find that people tend to not understand what red actually means, or orange. They may think it's the air apocalypse, but orange is unhealthy for sensitive groups. For example, particularly sensitive people should avoid prolonged or heavy outdoor exertion. So it's not as bad as the color would suggest. So we made sure to put these recommendations really front and center in all these products. When we have fires that have smoke plumes that don't get picked up by our regulatory network or any of these low-cost sensors, we'll go and install temporary monitors that ultimately get plugged into our air quality index map. Next slide, please. So 365 days a year, 366 during leap years, we issue daily and hourly air quality forecasts. We also provide a product that recommends the best time of the day for outdoor activities. We find, in Southern California, unfortunately, air quality is pretty bad all summer, including late spring and early fall. And we don't want to tell people don't exercise outdoors, but instead we want to tell people, pick times of the day where the air quality is better to do your exercise. During big fires, we also publish predictive air quality advisories, letting people know where the smoke will go over the next 24 hours and what you should do to minimize your exposure. We're working with our local National Weather Service offices to deploy these alerts through their official channels as well. And then we also do a lot of outreach to the public and the media. We issue press releases and reach out to local media during wildfires. We do plenty of media interviews and answer hundreds of phone calls and emails from the public. Next slide, please. So we also provide extensive guidance on our website. So just as some examples, I put on this slide here. So we focus on what to do to prepare for a wildfire, how you can protect yourself during a wildfire, and how to clean up after a wildfire. We also provide guidance that's tailored more towards school children, and we use social media to really get the word out about these. And then next slide. And then my last slide is I just wanted to briefly touch on our Rule 444, which addresses wildland and agricultural burning. So we know that prescribed fire really reduces the overall emissions that you can get from wildland burning, from wildfires. And it's beneficial not only for safety, but also ecosystem health. So our rule is designed to ensure that this burning happens on days with good dispersion and low expected air quality levels, so that we don't further exacerbate air pollution on days that have high air pollution levels. And that's all I had to show, and thanks for your attention.
Thank you so much, Scott. It's really fascinating to think about sort of the relationships between all of these things. Our last speaker in the session is going to address a little bit sort of how, something that integrates impacts to air and water and soils through growing food. So Julia.
Thank you, Sabrina, and thanks for having me today. Again, I'm Julia Van Soelen Kim. I'm a food systems advisor with UC Cooperative Extension, and I'll be speaking about a study I did with colleagues at UC Davis and Cooperative Extension, as well as with community partners, looking at post-fire produce safety for backyard food gardeners. And this is part of two studies. Our sister study looked at post-fire chicken egg safety. And that was a little bit too much content to cover in today. I also want to underscore that the information today really focuses on the effects of wildfire smoke and ash on backyard and local produce. But this is looking at sites exposed indirectly to poor air quality events and ash, and not on sites that actually directly burned in wildfire. Next slide. The first thing that I want to share and underscore is that context really matters. And this study looked at the Sonoma complex fires that happened in October 2017, which were really unique because they were very hot. They burned a very large urban area with lots of structures, and there was widespread smoke and widespread ash and prolonged poor air quality. Next slide. So in response to community concerns, because this fire happened in October during the height of our harvest season, and home gardens, community gardens, school gardens, and local farms were just overflowing with bounty, but all of that produce had lots of ash on it. We were able to mobilize 15 volunteers across 25 garden sites to collect over 200 samples of leafy greens. And then we froze them and saved them for later analysis. And as the months went by and we worked on fundraising to analyze those frozen samples of leafy greens, then the community's concerns shifted more towards the possible contamination that might be in our local soils. And so that was a new concern that emerged. And so in response to that, we chose 3 sites of varying distances from the urban burn and took composite soil samples. Next slide. Looking at the findings of those samples, specifically the leafy greens, we found that there was low concern from contaminants. And each of these points has a lot of caveats that I'm happy to go into offline. The first finding was that there were no Proposition 65 regulated heavy metals in 12 of the 13 samples. There was an exception around nickel, which I could explain offline. There are also no detectable polycyclic aromatic hydrocarbons, or PAHs, or polychlorinated biphenyls, or PCBs. And no dioxins or furans were found in 12 of 13 samples. The sample with detectable levels was below California's no significant risk level under Prop 65. Next slide. The next findings related to the soil that we collected. And we found that there was low concern as well in the soil samples, but that more research was needed. Specifically, we found that heavy metal soil concentrations were below our county's post-fire cleanup goals, which reflect what's in the native soils. The soil samples did not have any detectable polychlorinated biphenyls, or PCBs. And the site closest to the fire had the highest level of dioxins and furans found at levels that exceeded EPA and OES soil screening levels, but those levels diminished the farther we got from the urban burn perimeter. And in addition, it's really important to note we were unable to confirm whether these contaminants were present before the fire or whether they were as a result of the fire. Next slide. So we wanted to take these findings and put them into the context of the multitude of health concerns that arise from a wildfire. And so we wanted to use a method of cumulative risk assessment to attempt to understand the total risk from multiple exposures in multiple media. And this method interprets risk in the context of other vulnerable and protective factors that might be present in wildfire context. And our study was able to find that there was a net benefit from increasing the consumption of local produce that was exposed to the smoke and ash, compared to the maximum, sort of like the most severe case of possible contamination from that produce. So we felt that it was a really conservative look at the possible risk of contamination, and we're relieved to find this overall net benefit from cancer risk reduction of eating leafy greens, which we know is typically healthy. Next slide. So people always ask, so is it safe to eat the produce after an urban wildfire? And we believe that of all the things to be concerned about following a wildfire, that produce safety is ultimately a low concern. And our results indicate low concern from health impacts of eating local produce exposed to urban wildfire smoke and ash, specifically in our context in the 2017 Sonoma County wildfires. And then in addition, our cumulative analysis further suggests that eating trace contaminants on produce does not provide a significant chemical exposure from an urban wildfire, and that potential cancer risk may be outweighed by the cancer risk reduction of the nutritional value of eating leafy greens. Next slide. We want to underscore again that during a wildfire, the #1 thing to do is to protect your lungs first and foremost before being worried about what you might be exposed to on local food. And during wildfire events and during poor air quality events, we use this social media graphic to try and reinforce our message from our study. With that, I believe I just have one more slide of thank yous, including to the Bay Area Air Quality Management District who funded the study.
Thank you so much, Julia. Can all of our panelists who are part of the second session get your cameras and your voices ready to go to answer some questions? I'm excited that in this panel, I think we looked a lot at, take a step back here. So as a resident of Southern California, I know that we all experience sort of all of these things, right? Fire, and then what happens after the fire, and how does that impact our health? And how do other things happening in the world affect that as well? So I kind of want to start off thinking about that question of cumulative impacts and kind of building on what Julia ended with. So, many of the negative impacts of climate change to natural urban environments and human health are going to be cumulative. They're going to be synergistic. They may be antagonistic. And that goes for both sort of direct health issues like Scott and Julia focused on, but also safety and our ability to utilize our natural resources to support community well-being, things like having nature and having healthy watersheds and all of that. So let me start a little bit with this question, directing this to Julia and Scott, and I'll work sort of backwards a little bit. So how do you integrate fire risk with all the implications for physical health that you talked about, but how do you integrate all of that with mental health, and how did the pandemic complicate things? So please unmute. Yeah.
So I guess I could start a little bit. That's a really tough question. I don't really know how to quite answer the mental health side, but I can talk about how the pandemic complicated things. So, the guidance for a wildfire is remain indoors with your, windows and doors shut, run your air conditioning or an air purifier if you have one, close your windows, right? No natural ventilation. And you could imagine scenarios where pre-COVID, you could go, to a movie theater, or you could go to public places that are don't have natural ventilation during a wildfire, and would be somewhat protective. But COVID kind of throws a wrench into that, because you want to have good ventilation, right? Not only good filtration, which also is the same for a wildfire, but you also want to have good ventilation, in indoor environments, to prevent against inhaling coronavirus aerosol. So there's sort of these two competing priorities. It's especially apparent like in schools, for example, the guidance. I mean, there's some overlap in better filtration, and running air conditioning, but there's not complete overlap in wildfire smoke mitigation measures and COVID mitigation measures. So that's kind of tricky.
Yeah, having lived in Ventura during the Thomas Fire, where almost none of us had air conditioning because it's like, hot days in Ventura are 80. It was really tough. And that was again pre-COVID. Julia, do you want to touch on that? You did it a bit, but.
If it's easy to share the screen again to my slide number 6, cumulative risk, probably a different number for you. If not, I can talk through it. But basically, looking at our cumulative risk assessment, your question gets exactly at why we didn't want to just leave our laboratory findings standing alone and not share that broader context. So we know from a wildfire, go back to that sort of colorful, there, that one. So we know that there's health hazards from urban wildfire. And of course, there's that complex chemical mixture and smoke that's moving through the ecosystem. We've heard about soil quality, we've heard about water quality, air quality being affected. But in addition to that, when we look at the broader impact, there's also increased food insecurity. There's also increased mental health stress. There's trauma from experiencing wildfire, experiencing an evacuation, being part of a vulnerable group, like someone who is undocumented or medically vulnerable. And all of those health hazards are weighing on the physical bodies and the physical health experience of people in a community experiencing wildfire. And those have very real impacts into whether an individual will experience a negative health event or be more protected. And so all of the people in a region may be equally exposed to wildfire smoke and ash, but certain people are going to experience adverse health effects while others aren't because of the complex factor of vulnerability factors that they have layered on top of them or protective factors. So when we think about local produce, we can think of some of the protective factors that supports, like better nutrition from health promoting antioxidants. We can also think of quick and easy access to fresh local food for food insecure populations, and people who have access to home gardens may be more food secure, or local farmers may be donating their food during emergencies to local food pantries. And then we think of more longer term protective factors like a stronger economy and an air-connected community that a local food system can provide. We made this sort of framework before the pandemic was even a consideration, and the pandemic layers in so much more complexities around the cumulative risk of these wildfires in the context of a global pandemic.
Indeed, it does. And something that I really have struggled with too, as an extension advisor in areas where these large fires have occurred is, again, getting back to that trauma idea and what are the long-term impacts. So I want to turn a little bit now, similar question, turn back to sort of Jeremy and Sterling, and I'm going to sort of step back through our panel a little bit. So how do you address safety risks while kind of working with these traumatized communities? And I'm sorry if I'm putting folks on the spot. I know you're not mental health professionals, but it's a real challenge, I think, for all of us who are managing resources.
Yeah, for us in public works, we recognize that, the fires could be quite devastating, very traumatic for folks. And then, with the kind of climate change, we're seeing these fires go more into the closer to storm season, or actually in storm season now, which typically starts in LA County October 15th. And so they're going right after this fire trauma to now there's the trauma of debris flows that could come down and be just as devastating as you know, most of us know about Montecito. And so we take a very balanced approach to, you know, if we're going to be evacuating folks from their homes or recommending these evacuations and working with the first responders, we take this role very seriously. And we really we don't want to unnecessarily have people evacuate and then, you know, the storm doesn't materialize and, you know, they start to get evacuation fatigue. And when they really do need to evacuate, they think they're going to stay. And then there's that potential for, you know, debris flows impacting their homes and these communities. So it's a balancing act between these two of do we get people out or do we, you know, not evacuate, and so it's always a balance between those two.
And just to add to what Sterling is talking about here, and I, you know, I'm not a county emergency response or flood control person, so I don't have the authority to step in, but I've worked in plenty of California communities affected by wildfire and especially watershed emergency, you know, response type work. And what we do notice a lot is there's a general lack of awareness. So I mean, you know, to get someone to the point to understand that they're in peril, they have to be aware of what that peril could be. And I think, you know, LA County, Ventura County, you guys have been through it, you know, for over 100 years, having to deal with wildfire and post-wildfire flash floods and debris flows. And it seems like to get over, you know, the hump there, to get people to understand of what, you know, perils they may be faced with is a little less daunting. But in other California communities where they're really small, you know, less resources, maybe one engineer on staff, and I've worked in some of these communities. The solo engineer has never dealt with a wildfire in their city or county, and therefore their awareness is low, and the public information that, you know, that is provided is consequently low. And so I think really just you know, looking at the statewide issues, public safety, you know, getting people to understand that there are you know, potential hazards after the fire is put out, and what those hazards are, and using consistent messaging, consistent terminology is really important. You know, can we do better? Yes, we can do more pre-wildfire you know, planning work and assessing what could happen if a watershed burned in terms of, you know, debris flow volumes and flash flood impacts, inundation areas, and those could be incorporated in county hazard mitigation plans. We could do more for sure.
And just to add a little bit to what Jeremy said, I think for us to, you know, be able to go out and go home to home and explain the potential risk that they may have one-on-one, and looking at that individual's home and kind of talking them through it, I think goes a long way too. So that when these big storms do come and there is this potential, they understand what the risk is. And I think that's an important part of the measures that we take after fires in order to go out there and talk one-on-one with people.
Yeah, and it's so hard. I think about, you know, again, working with colleagues who might have been in smaller communities and even Montecito compared to LA, and can have that one-on-one relationship. And with, you know, something like, I don't know, what do we have, like a 15th of the country's population? yeah, the challenges are big. Okay. So Toby and John, you're gonna kind of get your shot at this as well. So a similar question, how do we balance these sort of acute watershed health and water quality issues and impacts with thinking long-term about ecological resilience and habitat function and habitat health?
Well, I guess I'll start first. I think, and I've heard it in the other panels, and I know we discussed it with the study that the ELARC group is pursuing, is that there just isn't enough data out there to really understand what the fires that we've seen historically, how they've directly impacted our watersheds and our water quality. Certainly we're seeing them with a lot more consistency and frequency and intensity. And so we need to understand historically how they impacted us, how they're impacting us now, the persistency, fate, and transport of the pollutants in our watersheds. And then of course, balancing it, I know we discussed really briefly because it was only 5 minutes, a model aspect that we're including in our watershed, which is really the first in the region. None of the watershed models we currently use for our watershed programs include a climate change or fire metric. It just wasn't considered, and now it's very much a consideration. We're really excited to kind of develop that so we can understand, again, what's happening now, and also implement some climate change scenarios that look at historical extremes, right, extended dry weather periods, and how these are going to continue to sort of exacerbate the impacts that we're seeing. And I think once we get some of that data in our own region and connected to regional studies that are happening, and also statewide studies, we can take a better look at what we can predict the watersheds are going to continue to look at or look like as we continue to have these fires happening in our areas. Like I said, the Upper LA watershed is so wide and so diverse. Our agencies are either open space or highly dense residential areas, so it's very complex. But we do know from earlier studies from SCORP in 2009 that the Upper LA River was used as a reference station for the Ballona Creek watershed, and we clearly are no longer a reference station. So even in the last decade, we've seen tremendous changes just happening in our own watershed. We're really excited to kind of start gathering some of that information and sharing with local collaborators so we can get a better understanding. I think for us as watershed managers with respect to habitat and beneficial uses of our rivers, we obviously, our programs include a lot of infrastructure that we're implementing. So green infrastructure projects that are diverting, mitigating, and trying to clean up the stormwater sort of naturally in these great multi-benefit projects. For us, the study is going to also help us understand how these pollutants are coming in and at what sort of factor, because obviously we're designing them with a certain pollutant load in mind. And if that pollutant load is changing, we want to make sure that that is a consideration as we're choosing and sizing these projects and making sure that they're continued to be not only maintained, but also working with the efficacy that we intend when we put these projects in. I don't know if Matt, you want to add anything to that? He's also here, my co-presenter.
Not at this point, no. I think that covers it.
Yeah, I guess I'll just add, it's a very hard question to answer. From a soils perspective, I don't think we're going to be able to learn more about the impacts of fire on soil because the impacts of fire on soil are so diverse and hard to study. And the more we learn, the more confusing it gets because every example is a little bit different, right? And so it almost confuses the situation. But what I can say is we're part of Mother Nature's experiment and we are learning as we go. And in terms of how natural ecosystems function, we're seeing it. And I think we as Californians are way ahead of the game because we're experiencing it and we're building that collective understanding of the implications of it. And now you even hear it, our politicians and big decision makers are talking about important things like ecologically managing our forest. We're not trying to prevent fire or our vegetation from burning, but we're trying to figure out ways to burn our vegetation and thin our forest so that we don't have these catastrophic outcomes. So in some ways we're learning through in the hard way, I guess. So that's all I can say to that question.
Yeah, I do a lot of work. It may not have come through, but my sort of first primary job is working on aquatic habitat issues, and I do a lot of work in the LA River. And yeah, it's interesting to think in the watershed overall, the idea, and this goes back to Marty's presentation in the first panel, the idea that we are right on the edge of realizing and seeing not so much the type conversion related to invasive species, but the type conversion simply related to changing climatic conditions. So I know after the station fire, there was a lot of like, let's go plant trees in Angeles Forest. And my first thought was always, are we sure it's still tree habitat? Is that what we should have there? Now we're going to be talking a lot more. I do want to give a plug to our next session on September 30th, same time, where we're really going to be talking about habitat in a lot more detail, vegetation and wildlife impacts of fire. So just a heads up for that. So one question that I do want to make sure to ask everyone is, well, I think I'll start with this one actually. How can other researchers and other data sources and other kinds of science help you with the research and the projects you're conducting? And Dawn, I'm going to start with you since I took your slide out about this.
I know, I was like, where is it? That's okay. I had some good notes so easily. Like I said in the presentation, we're still finalizing our design. Obviously, there is a lot of there's a lot of people to consider. We obviously apply for Safe Clean Water Fund specifically for our agencies with respect to our stormwater management programs, our TMDL compliance, like I said, our BMP effectiveness and looking for some regulatory relief, but we're certainly open to expanding our study. There's a lot of people from academia here. CAL FIRE, there's lots of opportunities for us to build and expand in the study. And so we're open to discussing with anyone on how we can kind of move our study out, connect with things that are happening. Obviously, if we can share data, that reduces a lot of redundancies, not just in efforts, but in funding spent. And as I mentioned, we do have a website, the Upper LA River Group. It's that lovely acronym, ularwmg.com. I'll put it in the chat. The model that we create will be housed in a web-based platform on our website for the public to use. So we're really excited about that so that it'll inform the public and the communities on the impacts of wildfires on water quality and hopefully used as a template across the region. But if our presentation, shows some aspects that anybody is interested in, I know there's already some notes I took on several of you, please do feel free to reach out to us. We're more than happy to expand our efforts and make sure that the study that we're putting forth encompasses not just our own agenda, but other inclusive agendas in the region.
Yeah, so thank you so much for that. I do want to say I'm really interested in reaching out to you in particular to think about how your work can articulate with the recently completed LA River environmental flows study that Squirt just did. And then more broadly, just a whole bunch of really neat studies that have come out trying to assess and understand biodiversity throughout LA and the kinds of things that impact it.
Yeah, I'll just briefly mention that. I know we received some data from Ventura County and they've done some work. They didn't specifically target fires. That's what we're finding is a lot of groups aren't specifically targeting fires, but like us, they're out doing regular monitoring and they're seeing some upticks during the regular monitoring with respect to heavy metals, nutrients, sediments, and some other post-fire related pollutants. But Ventura did have some information on bioindices that was one of those things we were like, that's a consideration. We obviously have toxicity testing requirements at our watershed, but as you mentioned, with increased sedimentation, you are going to see a change in habitat. Most people don't think LA River has a habitat. There is one, even outside of the soft bottom sediments, and animals do live there. And so when you start to add those sediments and those other pollutants, you're going to see a change in the indices. So that was one area we were very interested in possibly expanding. And we have that option through Safe Clean Water funding to go back if we have, some additional needs for funding. So we'd be more than happy to talk about that offline, certainly.
Great. I do want to thank everyone so much for being part of this panel. I hope it came off how excited I was to really try to integrate all of these different fields and all of these different issues. Because that's what communities need to do at the end, right? Is integrate all of this stuff. I see that Eileen is here, and I know we're a little over time, so I'll hand it back to her, and she can direct us on what to do next and whether we can thank everyone, but have a little time to continue this conversation.
Yeah, I'm here to let you know you have a couple more minutes, and then I'm going to ask you to wrap up, Sabrina. We are a little over, but this is an important conversation. I want to give folks a chance to kind of give their final thoughts, and then you need some time to wrap up. So I'm going to hover here for a few more minutes.
Okay, and again, I just really want to thank everyone who joined us today. I'm sure there are participants who need to head off, so thank you, and please complete that survey, and join us next time on the 30th, and then for our third session on the 14th, and look at all the great resources that have been compiled on the symposium website. So now I'm going to ask some very specific questions, I think, or at least a little bit more specific. So I'm going to ask Toby this, but I think others might really think about this too, because it affects how people interact with nature, it affects flows, it affects all kinds of things. So the question is, how does the season in which a fire occurs affect severity, and therefore erosion, microbial and plant succession and recovery? Could spring or winter control burns help us avoid some site degradation due to our late summer high severity fires?
Yeah, I think it does. Absolutely. It's the conditions that give rise to the hottest fires that burn the longest is where you get most damage to soil. And instances where you have fire that is not as hot due to fuel moisture and instances like that, it ends up being a beneficial outcome to soils. And microbes aren't even fazed by it. So definitely the season matters in that respect.
And I know it matters a lot from the point of view of what you can try to do in terms of erosion control. That's something I've worked on a bit, like what you can apply to soils, especially when we think about restoring vegetative cover. So many of our fires, like the Thomas fire, it's like the hot, dry season, and then the next
there's no
day,
time. Yeah,
so when we have spring fires, there are some sort of natural responses we can think about and rely on, but these.
Yeah, I mean, and those aren't the ones that we're concerned about for erosion usually, right? The spring and even if there was a winter fire, they're just not going to do the damage to cover that's going to cause soil erosion. But yeah, those hot summer fires followed by rainfall, you're just not, there's no restoration at a significant scale that can happen.
Down here, our summer's a little shifted. So if you want to consider September, October, November, when most of our large fires occur in Southern California, sort of a continuation of summer. I'm always surprised when people are shocked that it's hot in November.
Yeah, and that's a good
November.
That's a good point, though. People do claim in the rangeland community that we used to get more gentle rains in the fall, which really helped with germination of the annual grasses that would, after the cattle would eat the grasses, it would germinate, and then it would form a protective cover on the soil for the heavy winter rains. And so by not having a gentle fall rainy season, there's just no chance for anything to establish and do minimal protection of the soil surface.
Yeah. Yeah. Well, the question that I had wanted to kind of end with today was, how do we fit community priorities in with all the science we've talked about today, from climate to weather to soils to water, et cetera, air. Sorry, Scott, air. How do we kind of we talk about planning for emergencies based on the best science and engineering knowledge, but as Sterling well knows, sometimes there's a competition with community interests and priorities. I don't know if we have time to really delve into this too much, Eileen, but I do want to say we're going to come back to this and talk about it a lot more on the 14th as well.
Yeah.
I should probably let Sterling respond since I put him on the spot, but
I'll let Sterling have the last word, and then that'll kind of set the stage for the continuing the conversation in day 3.
Well, definitely when we do our projects, we take into consideration the habitat and the community concerns. And often our projects, we're always looking at having the least amount of impact to the habitat and the environment. And we'll adjust our projects based on the community needs and that habitat as much as we can. And if we can avoid it, we certainly go through extensive lengths to mitigate for those impacts. And our Devil's Gate project, we've done an amazing job in restoration of habitat surrounding the reservoir. And with that, we were very excited to see that right in the middle of our restoration area that we have worked very hard to bring back with the natives and get rid of the exotics. We have a nest of the least Bell's vireo for the first time in that local area that had been documented and had very successful hatching of the babies and actually ended up fledging there. So we're very proud of those added work that we do as part of our projects to support the healthy watersheds.
Certainly, that's a great way to end with the fact that there's
a great segue to our next session on the 30th.
Yeah, in which we'll be focusing in more on the wildlife, certainly. So with that, I'm going to transition us to a close. We've covered a lot of ground today, quite literally. And in each of you has contributed so much to that conversation and our understanding. And I guess if I have to kind of come up with 2 takeaways, it's like we've got a lot of information, a lot of good data that is helping to inform our practices and the opportunities to prevent and manage and be resilient in the face of wildfire. But there's also a lot of hope that I heard, and that's through the educational opportunities, the collaboration amongst agencies, and the listening and the learning from others. And we started off the day with a land acknowledgement of the Native peoples who are and have been the caretakers. And we know that there's a lot of cultural knowledge that we're bringing into this conversation in the next panel days. So we look forward to having not only their voices, but other voices join this conversation. And I thank you, Sabrina, for managing and putting together this panel. Thank you, Jeremy. Thank you, Toby and Dawn and Sterling and Julia and Scott for contributing your expertise today. It's been really great to have the conversation, and we're looking forward to continuing it and hope you'll be able to join us in the next 2 days, September 30th and of course, October 14th. And so with that, I'm going to once again thank our sponsors who again have generously provided us an opportunity to bring these panelists today and our panelists in the days to come. We have a number of staff that has been working behind the scenes. And so I'd like to acknowledge both Drew Reedy and Elise Eberhard, who have really led the logistics behind today and will be in the coming days. And I have a number of other staff that I don't have the list in front of me, but I appreciate all of their hard effort in terms of making sure everything goes smoothly and keeping us relatively on time, although we always go over time. I hope you'll stay with us for our next part of the session, which is our poster presentations. we're getting a little bit of a later start than we had hoped, but I hope you'll be able to stick around, grab a quick bite to eat, and keep the volume on. And with that, I need some direction from my staff as to whether or not we're good to start. And I see Ari. Ari, it's so good to see you. Ari is a former Council for Watershed Health staff who is now at UCI. And I am not familiar whether or not I'm going to be sharing my screen or if I'm passing that to you. So that's where I need some direction. And if you're ready, I'm going to pass the mic to you and I'll wait for my direction.
They'll be sharing their screens.
Great. Okay.
Great. Thank you so much, Eileen. Can everyone hear me okay? Great. I'm going to, oops. So first of all, I'll just briefly introduce myself. I noticed that I cannot share my screen while someone else is sharing. So I think, okay, great. So let me just briefly introduce myself. My name is Ariane, and I am a PhD student in civil and environmental engineering at UC Irvine. I'm so excited to be here with you today because I worked at CWH for 2 years after undergrad and before grad school, and I'm just really excited to come back and share the new work that I've been doing, which is very related to everything in the symposium so far. So let me just start off by explaining this photo is of a floodway in Riverside County during a 2018 storm following the Holy Fire in 2018. So it's a winter 2019 storm, and it just shows the amount of infrastructure damage and possible property damage that could happen as a result of post-fire flooding. And so that's the focus of this talk is going to be today. So as many of you know, here in California, we experience a fire flood cycle in which periods of drought lead to the right conditions for wildfire, and then storms during the following wet season can produce flooding and debris flows that are laden with a lot of sediment. And then the rains produce vegetation, which completes the cycle. So debris flows like the ones in Montecito following the Thomas Fire in 2018 can cause significant loss of property and life. And what the trend that we notice now is that the frequency and severity of large wildfires in California is increasing. And this is partially to do with climate change. You can see that 8 of the top 10 largest wildfires in California history have happened in just the last 4 years. And in addition to these kind of climatic factors, urban development is also expanding at the wild and urban interface, the transition zone between undeveloped wildlands and urbanized areas. And so more people are at risk of these post-fire floods. So flood control agencies need better tools for estimating post-fire flood and debris flow risks that can aid in long-term emergency planning, which many of our speakers have talked about. And so our group has developed an original conceptual model of post-fire flood and debris flow risks that considers the impact of flood control infrastructure. And I'll just briefly say that operationally used post-fire debris flow models developed by the USGS, they predict debris flow likelihood and magnitude at the watershed scale, but currently, they don't predict the risk to downstream communities or account for the role of flood control infrastructure, which is the gap we're trying to fill. Oops. Okay, so we can think of, let me explain the idea behind our conceptual model. We can think of post-fire floods as a compound hazard, meaning the interaction of multiple hazard drivers, in this case, fire and precipitation, that can cause a sequence of events with a cumulative effect. So here you see a mountain canyon, a mountain watershed, and the way that flood control infrastructure works is that when it rains and the storm is at or below the design level of the infrastructure, the runoff and fine sediment are conveyed to a debris basin, which captures the sediment and allows only runoff to flow safely past the community. So as long as storm events don't produce a flow rate greater than what the channel was designed for, the community is protected from floods. But when a wildfire occurs, it strips the slopes of vegetation, increasing runoff or the potential for runoff and erosion. And storms following the fire can entrain sediment and debris on its way to the debris basin. If the debris basin fills completely, then something called bulk flow, which is a mixture of sediment and water, can enter the flood control channel. And the channel is not designed to handle bulk flow, so it can clog and or have its capacity reduced, resulting in flooding that spreads, due to the flatter topography in this urban area, it can spread very far away from the channel and cause something that we refer to as unpredictable flooding. Okay, unpredictable flow paths rather. Okay, so very briefly, on the left is a full debris basin being excavated in Riverside County, and top right is a flood channel that has filled with sediment after a post-fire storm, and bottom right is a community that is flooded after the Holy Fire in Riverside County. So to give you an idea of what the risks are like. So essentially, we have looked at the hydrology manuals of LA County, Ventura County, and tried to generalize the design standards that are currently used for this flood control infrastructure. So two key design criteria used in Southern California are the return period of the design storm, essentially how frequently on average a storm of this size occurs. And LA County uses a 50-year design storm, Ventura County uses an 100-year design storm. And in general, many Southern California counties use a bulked discharge, which means they add a factor that accounts for the sediment in the flow. So we've modeled this, and we also have looked at maintenance frequency. And so with Riverside County, we have had conversations about when they clean and how much. And so just to give you an example, they can clean during the summer when the capacity is reached, the infrastructure capacity is reached after a fire, and then sometimes during the wet season with some amount of time between storms. And then I'm almost finished here. So so to give you an idea of how the model works, or the things that the model can produce, top left, you have a time series of precipitation for 100 years. So you can look at very long time periods for long-term planning. So if we just look at this large storm that happens after 20 years, this is the largest storm on the 100-year record. However, there's no fire that occurs at the same time. And as you can see on the right-hand side, which shows the overbank flows in 3 management scenarios. The first management scenario is a less conservative design standard and low maintenance, and that the infrastructure is exceeded because of this large storm. However, the second scenario has a bulk design standard, so it's more conservative, and the third scenario has bulk design standard and frequent maintenance. So essentially, this large storm only produced 1 exceedance in the least conservative management scenario. However, if you look at the series of smaller storms around year 10, there was a major fire that happened, as shown by this bulking factor chart. And so the combination of rain and fire produces many exceedances in all 3 scenarios. And you can see that the number of years in which infrastructure exceedances occurs decreases as the management scenario becomes more conservative. So this is just an illustration of what the model can do. And so I know I'm running out of time, but these are the kind of questions we're looking to answer. And no model that we know of can answer questions like this about design and maintenance. And finally, I just wanted to acknowledge the collaboration we have with Riverside County Flood Control Water Conservation District, and we are always looking for input on how our model can better serve and be useful to managers. Thank you.
Thank you, Ari. I know it's kind of like a speed session right now, but you got through a lot of information, and I know you're going to stick around to answer some questions after we get through the other presentations. So we'll go to our second presentation with Anja Davidson.
Yes.
Allison, are you ready to go and share with
I'm
us
ready
the
to go,
potential?
but I think my face doesn't show.
Let's see, try your video down below.
Yes.
There you go. We
my
can
face.
see you now. Great.
Thank you so much.
You're on.
Okay, I'm going to
Okay.
share my screen. Do you see my screen? Do you hear me well? Is it good? Yeah.
Yes, you are good.
Perfect. Thank you so much. Okay, so I can start. Do you still see my screen like this? Yes. Okay,
yes.
So I'm going to start then. Hello, everyone. My name is Anja Davidson Rorilson. I'm a PhD student in environmental engineering at UCLA, and I'm interested in developing solutions to mitigate the impact of wildfire on water quality. So first of all, why I'm interested in this subject is because, as Professor Marilyn Raphael said this morning, we know that the climate change are going to make the wildfire more intense, more severe, more frequent. And this is happening right now. Like, this is the screenshot of New York Times 2 days ago in Sequoia. And we know that the impact about the air quality is known, but like, that's why with the COVID, it makes it more worse. But like, we don't know, like we don't really heard about like the long-term impact of non-water quality. So this, for example, is a picture of in Colorado River because of wildfires. And I'm glad to hear all this presentation this morning. So I think you can know which contaminants are concerned, especially Don Petschauer talk about these contaminants. And these include total suspended solids because of erosion. There are also polycyclic aromatic hydrocarbons, DOC, heavy metals, nutrient, and DBP precursors. And if you take a look, these are just the processes and mechanisms which occur from the upstream to downstream. And these figures come from a review paper we have, which is under review right now, and I'm the leader for this paper. And you can see the different mechanisms which occur and how like these contaminants affect the water quality and which processes are occurring in the water. So here you can see PAH, most of them are volatiles, but like some of them bond and go to the water. You can see TSS, which occur because of erosion, and there is a lot of water coming to downstream. And you can see also DOC, which is a DBP precursor, by the way, which can affect the water quality. And why is it important? Because these contaminants can pollute the surface water. And the fact is that in Southern California, the water is scarce. And we want to protect this. So this is the objective. We want to protect the downstream surface water and especially water supply in order to decrease the public health concern because of DPP's precursor, as I talked about during the disinfection process, which occurs in water drinking supply, in drinking water supply, sorry, and also to decrease the environmental pollution. And what is the idea? The idea is to implement green infrastructure like stormwater biofilters here, as you can see, to limit the release of metals in the water. So what comes out from here is like a safer, a cleaner water. And for that, how I did experiment and have some results. But like for the experiment, I collected ash in after the Palisade fires in last June in Topanga State Park. So we collected some ash, and also natural stormwater. We used that to collect it in Ballona Creek, and we're used to do that because of our lab is doing a lot of research on natural stormwater and green infrastructure. So yeah, so these are the materials I used, and now we want to see. I did 2 experiments. The first thing is, as Don Petschauer said, we want to understand the pollutant load in the watershed. And for my case, it's like to understand the leaching of the contaminants in the biofilter environment. So I did a batch experiment to understand that. And then I did a column experiment to understand the removal capacity of biofilters. And here, what I've done is like I mix ash with 6 different solutions. And the 6 solutions is rainwater, natural stormwater, synthetic stormwater, solution which mimics the root zone, in biofilters and also in the filter media, which is here, the pore water. So I have 6 solutions. And what we noticed is that in this 6 solution, we can see that there is elevated potassium. This is the blue one. And then I remove the blue one to see what other things we can see, which basically have sodium, silica, calcium, and etc. And then, and this I use ICP-MS for that. And then I use ICP-MS to see transition metals and also alkali metals. And you can notice that there is no selenium, mercury, and selenium, which is specific to the ash I collected, of course, but there is a presence of all other alkali and transition metals. And then I did the biofilters to understand the capacity, the removal capacity. I put synthetic storm water as an effluent, and I collected the effluent, which is collected for analysis. And I have 3 sand and compost columns, and I have 3 sand columns. So we are interested in sand and compost column because by definition, these are biofilters. And what we can see is with the 25 elements we have, we notice that if you see the sand here, there is an increase because the sand don't absorb anything. The sand is just to see like, oh, okay, there is a lot of contaminants coming out from sand columns. But what we notice is like the compost and sand can limit the spread of wildfire contaminants. Yeah, so I'm almost done. So there is no significant metal leaching from wildfire residues, but you can see for cobalt, rubidium, lithium, and arsenic, you can see that compost biofilters can actually limit and mitigate the release of metals. Because if you see the pink box plot, we can see that they are the same before and after the deposition of wildfire, while the sand columns increase the contaminants. So yes, so to conclude, I'm still working on this project. Actually, I'm doing the physical, I'm evaluating the physical function of biofilters because of wildfire residues. So I'm interested in hydraulic conductivity because the ash can clog. And I'm also going to do the biological functions, which means the germination and the plant growth of the vegetation of the stormwater biofilters. So yeah, so if you have any questions, please feel free to ask me. I know it's like I'm shorting all the time, so I'm done. But I want to thank my C-Lab, which is my lab, and my advisor, Professor Mohanty, for this work. So thank you all. Thank you.
Thank you.
Thank you. Yeah, please feel free to ask any questions.
Well, let's put the questions in the Q&A, and we're going to keep you around for after the presentation so that we can start to answer some of those questions, and then any ones we'll pass along to you. This is really important research. It certainly ties into what we'll be talking about next time around in terms of the wildlife and how we looked at certainly the vegetation's importance in soil in terms of the resiliency of wildfires. So thank you so much for sharing this. And I guess all these presentations have some relevance to how we're designing our communities too, which is of great importance to me. So with that, I'd like to move over to our third poster presenter. I'm hoping everybody is able to grab another little bite to eat or something to drink as we move to our third presenter, Diana Vasconcelos. And are you ready to go with resilient watersheds and fire management?
Yes,
Great to have you here today. And I'll pass it over to you.
Thank you. Can everybody see my screen?
Yes, we can see it quite clearly.
Great. I want to apologize because my Adobe app just crashed. So if you see a little bit of Google Drive here, that's why. Hello, everybody. Thank you so much for having me here today. My name is Diana Vasconcelos. I'm a project associate with the Local Government Commission. And today I'll give you a brief overview of our resilient watersheds and fire management fact sheet. California is still reeling from the economic and public health impacts of the COVID-19 pandemic. All this while entering the second worst mega drought in 1,200 years. Simultaneously, 2020 was named the largest wildfire season recorded in California's modern history and included the August Complex Fire, which is the state's first CAT fire. We all know that climate change will only keep accelerating warming, making droughts more intense and exacerbating the stress on our headwater forests. That's why we need to understand the drought fire flood cycle. Drought and fire intensification are intrinsically linked. Fire reduces carbon sequestration, releasing more greenhouse gases, causing air temperatures to rise. And this gives us dry vegetation, creating more fuel for fires. As a result of these wildfires, we have eroded landscapes that allow for more runoff and debris into our water supplies. Beyond the ecological impacts, the drought fire flood cycle has huge financial implications. 3 of the past 4 years have cost 10 billion annually in damage from wildfires, compared to the previous 50 years where costs average about 1 billion per year. Luckily, the state leadership is responding to these compounding challenges. AB 78, passed in 2020, provides low interest rate loans to private sector projects that address the state's climate mitigation and adaptation goals. Governor Newsom also spearheaded the development of the California's Wildfire and Forest Resilience Action Plan and advanced $1.5 billion in this year's budget for wildfire resilience activities outlined in this plan. The state has started to take advantage of the 3 primary ways to reduce fuel load. California is now planning to strategically thin at least 1 million acres of forested land annually for the next 10 years. This can provide a new economic opportunity, especially in rural communities. The biomass removed from the forest can serve as an excellent source of renewable energy and have the potential to generate new economic value. Now, when it comes to advancing prescribed burns, we know that this will require a mental shift. We just need more education to showcase the positive effects burns can have on ecosystem health and also on human safety. There are also regulatory hurdles that limit the effectiveness of prescribed fires. However, this is an area where policymakers and upper watershed managers have begun to turn to traditional tribal ecological knowledge for guidance. The practice of intentional burning has been used for centuries to keep forest ecosystems in balance, and it also promotes the growth of tribal cultural resources that have been largely destroyed by fire suppression. Despite all that, tribes are leading the way in studying and promoting traditional fire practices. For example, we have the Karuk tribe that recently released a study outlining the state's and federal barriers to effectively using prescribed fire as a management tool, including recommendations for reform. The Yurok Cultural Fires Management Council received a CAL FIRE grant for a project focused on fuel reduction through cultural burns of 300 acres of land. It also includes an important education component to spread the awareness on the benefits of prescribed burns. It is clear that we can't have adequate forest management without intentional coordination across jurisdictions and all levels of governance. But there are opportunities at the state level to incentivize this coordination by aligning regulatory requirements, coordinating funding streams, streamlining eligibility requirements across state agencies. The benefit of promoting regional collaboratives is that we can identify threats to forest health and coordinate with federal or state entities to address these threats. Local engagement is also very important. Public agencies should focus on education and outreach around the role of fire to promote the proper responsible forest management. Now, forest management and wildfire response training can open the door to workforce development progress and employment pathways, translating into economic benefits. And this could be essential in California's rural and mountain counties that have been the hardest hit economically during the COVID-19 pandemic. Thank you so much for having me here today. I'm very happy to share more about the wildfire fact sheet with you. And if you have any questions, please feel free to reach me out at my email, or you can put them in the chat and I'll be happy to answer at the end of the rest of the presentations. Thank you.
Thank you, Diana. It's great work, and it's really important to have a number of other perspectives come into this conversation. So thank you for sharing that. Our fourth poster presenter is Jeremy Klemick with SWA Group. And Jeremy, are you ready to present on learning to live with fire?
Good to go.
Great. Good to see you. Thank you so much for joining us.
Sounds great. So that means you can hear me.
Yes, and we can see your slides. We're good.
Sounds great. So happy to kind of be bringing this home for everyone today. And I'm going to touch on a lot of subjects that have been brought up earlier. as well. But as mentioned, my name is Jeremy Klemick. I'm with SWA Group. I'm a licensed landscape architect based here in Los Angeles. And recently I've participated in several advisory service panels for the Urban Land Institute. And so this is going to be a brief presentation just of some of those salient findings. We've touched earlier, native old growth forests, they were fire resistant and the historic burn cycles have been prevented. There is the modern forest management of fire suppression, and really the current status of our forest is no longer healthy. It's no longer really intact. And a lot of mismanagement since the past 100 years of growth has actually led to what we consider mega fires nowadays. So what we really need to do, we need to look at what creates a healthy or intact forest. A lot's been brought up on promoting prescribed burning, introduction of fire tolerant species, proper urban forest management as well, mitigating heat island effect and promoting urban, because we are promoting urban infill, and really looking at maybe new methods on how do we incentivize interventions in forest products to utilize these materials from the fuel reduction areas that may actually monetize some of this fuel reduction as well. So next, we kind of want to touch a little bit on what everyone's been talking about. And there are lots of research going on right now. There are maps, and there's more maps. And there's really almost what we're considering really a data overload. And how does the common person sort of understand what do these maps mean? And the idea behind trying to get all of our scientists and all of our knowledge together to really create a singular map for public understanding is something that's going to be key towards moving this forward. Not just for letting everyone understand the situations that we're in, but where we need to go next. And this also includes maps that have been utilized recently, let's say up in Sonoma County, and we're starting to look at them locally, and it was brought up, but water sources, fire access roads. A lot of these firemen that are coming from different areas are being brought in and have never actually been up to Sonoma. They're bringing people from California, from Los Angeles. They're bringing different firefighters into areas that they're not familiar with. And citizens there have actually been preparing maps showing where their hydrant connections are, how they can get around the roads, especially in the backcountries where no roads are actually labeled. Another thought that's been brought up is really kind of what does the WUI, the wildland urban interface, really mean? In simple terms, it's where the fuel feeding a wildfire changes from natural fuel to man-made fuel. However, embers spread. It was brought up earlier a little bit about ember casting, about spotting of fires, and natural fuel has started to ignite beyond just what was considered the original wildland urban interface. So development and new projects and new things that are being built are really going to need to actually be brought up to minimal wildfire standards. We also want to promote WUI education for training industry professionals, especially when we're talking about developers, architects, planners, contractors, and landscape architects. We're going to be kind of at the forefront of how these areas are being developed over the next several years, and it's going to make a very important aspect. Now, let's just talk a little bit about actually living with fire. And I'm going to bring up the local as well as the regional scale and kind of just hit a few highlights here. But when we're talking locally and we're talking about communities, really increasing turgid areas, whether it's through infiltration or agriculture, increasing defensible space, fire resilient planting, home hardening, ember suppression with irrigation. These are all techniques that are being employed in new developments that are being developed by landscape architects, developers, architects. And what we really want to do is study these existing and as well as the proposed precedents that are happening, not just in Southern California, but Northern California as well. There's going to be a lot of lessons learned. And what we're also noticing is that the public is starting to step up on their own, especially in Sonoma County. They have some citizens organized to prepare for emergencies. They're calling them COPEs. And it's really a well acronymed thing for coping with the trauma as well as what they're having to deal with up there. If you have a fire sensitive community, there's a lot of trauma that gets involved. Your children are coughing. There's issues. Do you really want to rebuild? Well, if you feel that there is a plan in place, if there is a wildfire protection plan, if you know how you're going to rebuild, it's what's bringing the investments back to these communities that are very much fire threatened. one thing that kind of starts thinking about not just the community itself is the adjacent communities. And we've started looking into areas where we can start increasing trail networks around these urban growth areas, which really starts putting in wildfire buffer zones and utilizing the agriculture as well to help maintain these zones. Now, it may sound a little bit kitsch, and we know we're not going to be using the beaver in Southern California to increase our floodplains, but we do use cows, we do use sheep, and we do use goats. And these are actually sort of a natural fire protection brigade that we can use and bring into and think about how to get these areas for prescribed thinning. So kind of on a regional scale, what we start looking at is that fire is a natural system. It knows no borders. So we need to come up with, for Southern California, from San Diego to Los Angeles to Ventura County, we need to start looking at what protective buffer zones we can create. What corridors can we actually look at? And really encouraging people across the board to cooperate, public, private, nonprofit. So it's such a fantastic thing that elements like what we're seeing today are really happening. And I'm kind of just going to close on the fact that Southern California, we are learning. As was mentioned earlier, the $500 million from Governor Newsom's landmark wildfire package was brought in on April 13th. On April 15th, $12 million went to the Conservancy, and Jessica brought this up right at the beginning. We can also look at programs. We are using goats. The goats helped save the Reagan Library from California fires several years in a row. So we're not behind the eight ball per se on this. We are really learning to live and thrive with the increasing threat of fire. And I think that that kind of lets us look forward. If we keep talking and keep working together, there is hope, and hope is what's going to help us progress. Hopefully I kept right around my 5 minutes. I know our time is valuable, but I could really get into depth a lot more.
Well, here's what I'm going to do. Let's see where we got everybody back in, and we can get everybody's video back on. We have some time. We're going to let this go a little bit longer. I know we're starting to lose some of our participants, but I'm really grateful for all of you that have that are sticking around, because it's really good work that we have right in front of us. And we've got kind of our own another mini panel amongst the four of you. So I can only see two of you for some reason. So here's what I'd like to do. I'd like to start off the questions by asking all of you if you've got questions of each other. You've heard each other's presentations, or something that I'm sure has resonated within each of your presentations. And so I'd like to offer the opportunity for each of you to ask a question, and then we'll go to the Q&A and see how far we can get. So Jeremy, you ended the panel presentation. So let's start with you to see if you have any questions of your fellow presenters.
Well, SWA is actually doing quite a bit of work right now in the Bayona Creek watershed, and we're working with both Culver City and LA County Public Works. So Anya, it's kind of interesting that I saw you were taking samples from the creek, and I saw that they're actually ongoing work that will possibly be able to inform what we actually let or move downstream, especially as we're doing our planting plans and planting pallets throughout the new bike paths that are daylighting into the creek. So I'm wondering if there is, if this research, is it going to be able to be informative in that type of a way as well, as opposed to just the actual quality of the water that's going downstream, but what we can keep from going into the stream, I think.
Yes, thank you for your question. So basically, what I've done is mostly we collected we just collected ash and the stormwater to do this field strip. We didn't yet collected streams downstream to analyze that, but I'm planning to do that because I'm curious to know what's going on. So the idea is we can because I asked a question to Don Petschauer, we can wait, not wait, but if there is a wildfire and we know there is a creek downstream, and I know it happened for Malibu Creek because I read a paper about that in Malibu Creek. There is a creek, and we know that the wildfire has impacted this creek. We can indeed collected. We can do feed trip, which means collected regularly some downstream water to analyze the different contaminants in this in these samples. But does that answer my question, Jeremy?
Yeah, I think it's informative in that you will be looking into it, and the thoughts are definitely there because it will be informative because it's looking at what actually goes into the water besides just what gets dumped, what is coming from the ash in the air, which is, I think, kind of an interesting take.
Yeah, definitely. I'm like, yeah, I'm really interested in also want to see what's happening inside. So, because I know there is a lot of paper in Colorado, because here in Colorado, that's why I saw the picture of like Hammond fire. And there's a lot of research paper from this, from the University of Colorado. And there is not so much in California. And maybe also because I know there's a lot of fire, but maybe not a lot of precipitation. But yeah, we want to know, like in LA, there is so much research to do. And yeah, there is so much needs in California, especially in LA. So I'm really looking forward to that.
Anja, do you have a question for either Ari or Diana or back to Jeremy? And I'm putting you all on the spot, so it's okay if you want to pass. We've got some questions in the Q&A. So if you don't have a question, I have a question for you.
I want to ask Ariane. I think Ariane, you talk about the debris. So debris coming out from. Did you choose, like, how did you choose your area, your location when you do the modeling?
Yeah, that is a great question. Thank you, Anya. So currently our model has not been applied to any study area yet. All the results that I showed were kind of using arbitrary, what we call model parameters. So it's like a hypothetical watershed. But the goal of our project is to look at watersheds in Riverside County, who we're working with as a partner, and identify there have been recent fires last season in 2018, and kind of use data that the county has already collected to kind of calibrate our model to those watersheds and determine in the future how severe and frequent post-fire floods will be. So yeah, Riverside County for now.
Great, thank you so much.
Thanks.
Ari, do you have a question that you'd like to pose, or do you want a question?
I have a question for Jeremy. So I took a wildfires class just last year, and I learned from someone in our department that actually there's recent research that shows that fires aren't that common in the WUI, but the fires that do happen in the WUI are very kind of salient because they cause the most property damage and things like that. I guess I'm kind of wondering, is that a trend that you've heard about? And as we try to like live with wildfires, how do we kind of raise people's awareness that, you know, if you're living out there, you might not be able to get insurance, and all, like how can you kind of coexist with that risk?
Your question touches on multiple items that I'll try and hit the most important ones for my aspect of it. So number one is there is an increase in what are called mega fires, which are large fires as opposed to what historically would be low fires. So a low fire as opposed to a catastrophic fire, the low fire does very little damage, burns the undergrowth. You kind of saw some of the models shown earlier, how it kind of breezes right through. However, the mega fires that have been happening are becoming largely catastrophic because not just damage to homes and properties, which brings up your insurance capabilities, and it's really monetary damage that's becoming really drastic out in the WUI area. And so how do we get people to be able to, one, get reinsured and be able to rebuild out there? It's really going to be with planning and defensible space and home hardening, and really looking into what areas will insurance companies start requiring and start looking at. And that, I don't want to get too deep into what that can be because that gets into governmental regulation and a lot of people start throwing their hands up. But I think what we really want to look at is how do we educate the people that live out there, and how do we empower them to be able to use some of their own solutions? One of the things that's been looked at, and especially in Sonoma County, is changing, I think it's, I want to say appendix or Prop G, where they're not allowed to really do their own prescribed burns. because of the liability that you have to assess with that. So sort of lowering liability standards for homeowners to do prescribed burns might be one way to help them feel more empowered to take care of their own areas as well. So it's a tenfold question, and we can totally have a lot of good offline topics about it. But in short, it's the mega fires that are creating the most catastrophic damage. And until we can actually manage our forests well and bring them back in, which is what's been brought up, environmentally managing the forest is really being hit home by a lot of the presenters today. Once that's able to happen, then I think we'll see those decrease. And that's not even getting into the electric grid and resiliency for all of that and microgrids and power grids, but there's a lot of good knowledge out there, that's for sure.
Well, and we're excited that we've been able to bring some of that together today. Deanna, I want to see if you have got a question for one of your fellow presenters.
Yes, I do. Thank you. This is for Jeremy. I think he already touched a little bit on this topic, but I'm really interested in the social aspect of your work. You talk about the need for changing a mindset. Which kind of strategies are you currently using to promote this change in mindsets in the communities you're working?
So one thing that's really interesting, there is, especially that was brought up largely in Sonoma County, is the inequality and language barriers that are out there. And so really trying to look at not just the people that are trying to rebuild for their own wealth, their own developments, but the people that live and work and service those areas, or the people that live on the outskirts that don't actually have access to, per se, a lot of these type of talks. And how do you bring that out to them? And so really looking at trying to minimize the social inequalities that are out there is going to drastically increase the knowledge base. And I mean, it's not just language barriers, but socioeconomic barriers are going to be what really makes the difference here. We can all talk about what we think is going to be the best thing for everybody, but unless everybody knows about it, and unless people understand why we're doing what we're doing, which is part of why I kind of hammered home the idea of a holy grail of a one map that is really easy for people to understand, because we get it. We wouldn't be here if we didn't. How can we get other people involved? And I think, talks and sessions like this and broadcasting them to people that and really, it's a grassroots thing. Wildfire takes off in the grass, as will the conversations about it. So I think that's really what we need to start thinking about. It's not just internal conversations.
Jeremy, on that point, you mentioned the COPEs. And I'm wondering, is there some is there some kind of network? You mentioned a network.
God. So Sonoma actually, they have a COPE 101 handbook that they've put together, which literally lists the top 10 things that they recommend that someone should do, an organizer can do, or the communities can do on their own. And I think it's Sonoma County COPE 101. And it's kind of what it was is there's a lot of people that live up in that area that have organized businesses and organized things on their own. And so they found there was a dearth of organization in their local communities, and they stepped in to fill that void. Either they were retired or they were just really concerned. And so they started organizing this, and they've kind of come up with, it really is, it's a handbook. I mean, I'd love to share that information.
Please do, please do.
Yeah, I'll put it in the chat actually right now.
That would be great.
It's really cool.
We'll grab that and add that to the website, because it's those efforts that coalesce community, right? They help strengthen the community organizations that are already there in the community, and we can build off of that. Those are meetings that are already happening that we can kind of start to bring more information in and solicit information from these communities, because they're experiencing it. They've got lessons learned that can help inform the resiliency planning that needs to happen after a fire, but more importantly, what to do to help prevent that. And so it kind of goes back to what each of you have been talking about, getting this information out to those decision makers, including our communities, as well as the community-based organizations that can help move that information out to the community and then back into the work that we're all doing. Gosh darn it, this time has just kind of flown by, and I've got like a slew of questions that came my way as you all were talking. So I guess I'm kind of curious, just overall for each of you, there's a question for one in particular, but I'm going to ask it. So, and see if you've got any recommendations that come out of your research, your lessons learned, that can lead to, filling some of those gaps. It's like, where would you take, what's your next step in terms of the research that you're wanting to do, or partnering, who else do you want to be partnering with on your research? And so I'm going to go back to Deanna and see if you want to kind of kick us off with, where do you see your next step being, and who do you want to be partnering with?
Sure, thank you for that question, Eileen. I mentioned a little bit during my presentation the importance of regional collaboratives. I think it is necessary to start focusing in this cooperation and collaboration among different regions in the state. It is essential that we talk with all levels of governance and also jurisdictions, state agencies and public agencies, as well as nonprofits, and also include the community in every kind of effort related to wildfire. I think right now the local government commission is working with different players around the area, the Sacramento area. We're also working with tribe members, and we're working with other nonprofits to keep these discussions about wildfire and the future of California with wildfires, because it is a reality. The whole state was basically built on fire. Fire is not going anywhere. And if climate change is showing us something, is that if anything, it's only gonna get worse. So it's important to have these crucial conversations.
Thank you. And thank you for the work that you're doing on this. Ari, final thoughts on where you want to take your work and who you want to be working with on this?
Yeah, this is a great question. So at this point in my project, we have this modeling tool which can help flood control agencies and others plan for post-fire flood risks long-term. And so I think where we'd like to take it is, right now we're collaborating with Riverside County, but we'd also like to collaborate with maybe Los Angeles County or Ventura County or other counties that are looking at this long-term. And I know that some presenters talked about long-term planning, interannual variability. These are all kind of questions in the research that other models haven't really been able to address, but our model is kind of designed to look at questions of how do variables like precipitation and fire interact over time to produce hazard? How can we maybe maintain or even redesign the infrastructure to account for increased fire frequency and other things, other trends? And so collaborate with more agencies and maybe apply the model to different parts, different watersheds in Southern California, and like kind of scale it up. That's what we're looking at.
Great. Andrea, you want to kind of take it from there and let us know who you're interested in? Yeah.
I'm interested in local state government agency because as I said, there is a lot of research paper in Colorado, there's a lot of research paper in Alberta and Canada, but in California, there is not so much about the effect of wildfire on water quality. And especially because in my case, we would like to mitigate that. So first of all, we want to have more research about wildfire and water quality. And for that, we need funding. So we really want the state or local agencies to help us doing more research on that, to give us the tools and also what we need to make sure that we know better how our watersheds are impacted, how the water quality or the water quantity is also impacted in California, especially in LA. So that's what I want to say. But yeah, we need that in California.
Great. Yeah, we need all the focus down here as well as statewide. And Jeremy, I'm going to give you the last word in terms of where you'd like to take the work that you're doing and who you'd like to collaborate with.
Yeah, so we're actually at SWA, we're doing a lot of work with a lot of people. So it's actually really been fantastic, the partnerships that we have made over the years and the developments that we've been working on. We kind of started founding the fire science down in Orange County many, many years ago. And to be part of such a great legacy and continuing it is really fantastic. I've got family members that work for the Griffith County Park Rangers in their fire brigade. I've got family members that work for the U.S. Forest Service, and we're continuing to partner together talking about things. But I'm also working still with the ULI, and I'm working with SoCal ASLA, And we're kind of keep getting the word out as often as we can, whether it's about climate resiliency, urban forestry, wildfire resilience. We've got different folks from Southern California all the way up through San Francisco in our offices that are trying to tackle these projects. And I think the biggest hurdle in all of it is really not just getting the message out there, but making sure that we're not trying to, I don't want to say step on each other's toes or hide knowledge from each other. I think we really want to make sure that this isn't just a problem that we're going to solve internally. This is a problem that is not to just say global, but it is definitely regional. And it's something where unless we're all able to kind of gather together and work together, then it's just going to be working in your own little piece of the puzzle, and it's not going to really help. So that's kind of where my partnership is and who I want to partner with. And look, the short story is everybody. Like, I want to start working with everyone that I talked to on this call today. I want to start listening to the next couple symposiums. I want to start really kind of make sure that we know who we all are that are interested in this and how we can all benefit each other, because that's the only way we're going to be able to fit this whole piece together, I think, is with everyone being involved. You know, I think we shouldn't just keep it to ourselves.
Agreed. And that's probably the best way to wrap up today, and that it sets us up for more conversations. Thank you all for sharing your work. It's exciting to see so many different perspectives kind of inform this dialogue, and we thank you for joining us today. I'm going to share my screen one more time for the day, just as a reminder for all of you who have hung on until the very end. We're hoping to see you on September 30th for day 2. And again, I want to thank our sponsors and of course, the CWH staff. You know, I'm going to just name them off because Drew and Elise have just been amazing throughout the whole day. We've had Carlos and Clara Sophia, Andrea and Amanda behind the scenes as well. And I'm sure I'm forgetting someone, but we know that Cass and Ureli and Rumi have all had a hand in supporting everyone. So thank you, everyone. And we're looking forward to seeing you on September 30th. And with that, have a good afternoon.
Thank you so much.
Thank you so much.
Thank you so much.